All right, I think we're live. Good stuff. Hi, everybody. Look at that. What a crew. Have you all had coffee? Oh, good. Okay, good. Me too. That's going to be fine. Let me, look, you know the drill. We got to get a photo. Is that okay? You all accept my GDPR cookies? We're good? Okay. Just pretend like you're happy, okay? Here we go. Ready, steady, say open source. Oh yeah. That's awesome. If I use my big head to cover the light, I can actually see you all in the photo. Okay. Both things are true. Okay, so, oh my friends. So look, we've only got 3 hours here together. Very, very sadly. I wish we had more. But we have a lot to cover, and I mean a lot. And so what we're going to do, my hope, friends, is that we're going to start from the very small and move up to the very sort of high level, you know, and do so in just 3 hours, right? And I confess I'm very happy to be here with you all today. I really am. I last year, excepting, of course, the spring conferences, right? Those are, of course, my favorite shows. But after that, the DevOps 2023 was my favorite event of the year. It was just something special about last year's DevOps. Just will stick with me forever. I don't know. Anyway, I'm very happy to be back. Really, really happy to be back. We live in an amazing moment in time where technology and the sort of prevailing winds of society and what we're doing, all these things are sort of lining up and giving us this incredible opportunity that I don't think we can. We should be awake. You know, we should be awake and we should be paying attention. We live in an amazing, amazing moment. And so I'm just really happy to be here. This feels like, you know, if you had told me that I would have been so eager to be in Antwerp as the center of gravity for so much of the interesting technology in the world right now, I wouldn't have believed you 20 years ago. But here we are. It's truly a thing to behold. And I'm very excited about it. I wanted to show you some of the exciting stuff we're working on in the Spring team. But I confess, friends, that well, first of all, by the way, my name is Josh. I work on the Spring team. Here's my credentials, my coordinates. If you want to find me on the internet, you can find me. I'm a Spring developer advocate. I'm a Kotlin and Google developer expert, a Java champion, and of course, I'm at your service. So should you have questions, when ineluctably you have questions, please don't hesitate to find me here on the Bird website. Anybody here using the Bird website? Anybody? Nobody? Like 2 people. Yeah, it's really just, it's not great. And what about email? Anybody here using email? The only place with more spam than the Bird website is email. And so, yeah, so naturally these days, it's a little embarrassing, okay? I'm not proud, but we all do what we have to do to survive. I've become a YouTuber, and please, like and subscribe. It's called Coffee Software. It's not great. It's not good. Okay, I'm just going to go ahead and tell you that right now. You will make worse mistakes in your life, but not many, you know. But still, join me on the adventure there. It's going to be big one day, you know. This little channel of mine, and you know, I talk to people that are a lot smarter than I am, so there's that. But look, so I really wanted to show you some really cool stuff, and I was thinking, gosh, what could I show you? What would allow me to better demonstrate and exemplify all these amazing things upon which the Spring team is working these days? And I thought, well, gosh, you know. I could show you the old Spring Pet Clinic. How many of you have seen the Spring Pet Clinic? Right? The Spring Pet Clinic is a sample application that's been around for literally decades, right? And obviously we've updated it. I mean, here's the a change a week ago, right? It gets updated all the time. But basically, I don't know. I was thinking like we could show you this. And by the way, did you know that the Spring Pet Clinic itself was a GitHub organization, which in turn has dozens of different other variants, right? So if you go here, there's the variant that's all REST. There's one that's the Spring Framework-based, you know, Pet Clinic, the original one. There's the microservices version, the Angular version, the React version, the Kotlin version, the Vod and Flow version, the Istio version, the HTMX version, and config, and Data JDBC, and AngularJS, the original stuff, and Mustache. I mean, there's just a bazillion different implementations of that. So I thought, well, we could do that, you know, and I like the domain. I mean, who doesn't love the domain, you know, animals, pets, dogs, cats, these sort of things. I'm a big fan, obviously. And I thought we could show you that, but there's a lot to it, you know. there's a lot to it. There's just so many different variants and too many different things to show. And I wanted to sort of focus on a few select interesting things. So I said, well, okay, maybe we won't do that. Maybe we'll do something in the same domain, but, you know, simpler. And I thought, well, gosh, we could talk about pets. We could talk about dogs and stuff. You know, I mean, I'm a big fan of pets. I love dogs. I love animals. You know, everybody loves dogs. I love dogs. You know, I'm a big fan of dogs. I love all dogs except my dog. Okay, and this is where it gets a little awkward. I love all dogs except for my dog. My dog's a terrible dog. Not a good dog at all. He's a little tyrant. He runs around the house, he leaves his little rubber ducky toys on the floor to mark territory, right? And so if you dare to approach his rubber duckies, he'll take a limb. He will exact the revenge that you will not see coming, you know? So not a good dog. Very, very bad. Brazen, hostile dog. Bad dog. Bad. But nonetheless, we keep him because even terrible dogs, like my dog, deserve good homes, right? My dog, his name is Peanut. And there are 3 reasons why we keep him. There's 3 reasons why we have him around in the house. The first, of course, is that, like I said, all dogs, even terrible dogs, deserve love. They deserve a good home. They deserve a warm home. So that's part 1. That feels like sort of self-evident and obvious. Part 2, I'll just go ahead and admit it. Okay, I'll just say it out loud. It's ego. Okay, it's ego. And what I mean by that is, in my home, my partner and my daughter both speak 5 languages, whereas I speak but 3.5. And so if we didn't have that stupid dog, then I would be the stupidest in the house. That cannot stand. That will not stand. So we keep him around for this reason, right? And then also just being pretty self-evident. Again, he is stinking cute. I mean, just look at that, so cute. But these rubber duckies, these are his weapons of choice, right? He uses that to lay traps for people in the house. So this is why, even though he's cute on the outside, he's evil. Pure malice on the inside, okay? Not a good dog. And so he reminds me about another dog, about which I learned during the pandemic, whose name is Prancer. And Prancer was also not a good dog. Not a good dog. This dog, the owner of this dog, was looking for a new home for Prancer back in during the pandemic in 2021, right? April 2021. And she wrote this advertisement, this solicitation to rehome this dog. And this ad went viral. It was on the news, right? That's how I learned about it in the news. Do you remember watching news? Like actually sitting in front of a TV to watch news? During the pandemic, we did all sorts of things we're not proud of. That was one of those things I did. So anyway, this poor person talks about this dog, and she says, I have tried for several months to post for this dog to make him sound palatable. The problem is he's just not. There's not a very big market for neurotic, man-hating, animal-hating, children-hating dogs that look like gremlins. And she describes the dog as being 50% hate and 50% tremble, right? And continues that, let's see. Oh, I was excited to see him coming out of his shell and become a real dog. I'm convinced at this point that he's not a real dog, but more like a vessel for a traumatized Victorian child that now haunts our home. This dog, it continues, she says, Prancer wants to be your only child, right? Not good. That said, the dog is very cute, right? Also very cute, right? Like, so I can see the appeal. This is a cute dog, and even this terrible dog deserves a good home. So I thought, what if we built something in that spirit? You know, something to support adopting dogs. We could build a dog adoption thing. You know, and so I figured we could do that. But we're going to start really, really low and then work our way through the process, okay? Because, we have 3 hours. Let's explore the space, you know? So we're going to go here, as always, to my second favorite place on the internet. Obviously, my first favorite place on the internet, is production. It's always been production. I love production. You too should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It is better than Disneyland. But if you haven't been to production, you can begin your journey here at start.spring.io. Now look, friends, did you know that this start.spring.io has adopted some memory? So if I click on Groovy and then refresh, it still says Groovy. Neat. Okay, there's that. So you can choose what build tool, what language you want, and then it just stays that way. So I'll choose Maven, I'll choose Java. By the way, who's using Java? Okay, who's using Kotlin? Okay, nice. What about Groovy? Okay, very good. Look at that. Nice, 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 nice. Okay, so I'm gonna stick with these selections because I think they represent a plurality, if not the majority, of the room. Then we have a choice of what we want to name our service. And friends, here, I'm going to name our service service. And the reason is because I am amazing with names. I get that from my father. My father was amazing with names. When I was a small boy, we had a small white dog, and my father named him White Dog. Again, very good with names, amazing with names. That said, my mom, she tells me all the time, she says, "You're very lucky that I named you." And yeah, that's probably true. That's probably true. I don't want to know what he would have named me. Okay, then we have a choice around what version of Java we want to use. And friends, this is the perennial problem, isn't it? We have 3 radio boxes here. Notice that there is a missing radio box. I think a lot of you are thinking or imagining that there's a 4th one that should be here for Java 8. Now, Java 8 ain't great, friends. It's a terrible technology. It's long since irrelevant, way past its prime, in the distant, distant, distant past. So I would never use Java 8. And in fact of matter, if you want to use the modern incarnations of Spring, then you need to use at least Java 17 or later. But I would never use Java 17 either. Java 17 is a creakingly old, long since deprecated, long since irrelevant, ancient technology about which we speak never in polite company. No, I would use Java 21 if I had a choice. Java 21 or later, right? Java 23 just dropped a few weeks ago. It's actually in the rearview mirror right now, right? We're on our way to Java 24, right? And so Java 23 and later, Java 21 and later are amazing, amazing, technically superior pieces of technology. They're technically superior. They're faster, more robust, more syntax rich, more performant, more operations friendly. They're also morally superior. You won't like the look of sadness and shame in your children's eyes when they see that you're using Java 8 in production. Don't do this. Be the change you want to see in the world. Do the right thing. Use at least Java 21 or later. And look, friends, like I said, Java 24 is almost here, right? Java 24. At which point, if you're not persuaded already about the technological superiority of these revisions of Java, then let the math do the explaining for you. Remember, Java 24 is 3 times greater than Java 8, right? It's an amazing release. An amazing release. I'm a big fan. So we're going to use Java 21 or later. In my estimation, Java 21 is the single most important release of Java in the history of Java, right? And by the way, I had a poll. I put out a poll on the Bird website a week or so ago, and I asked people, given Java 21, Java 8, Java 5, Java 1. Because people don't remember. We didn't have a just-in-time compiler until Java 1.1. We didn't have generics until Java 5, right? I mean, there's actually a lot of really important releases out there, And then Java 8 has lambdas and streams, which I think are nice, but not nearly as important as, say, Java 5. We had enums, annotations, and generics all in Java 5. Can you imagine not having those today? I mean, the language would be very different. And then we have Java 21. And so thinking about that entire sweep of different things, I still think Java 21 is the most important. And we'll talk a little bit about why that is so today. So I'm going to use Java 21. And then we have some dependencies we want to add. Friends, we're going to build a service to help people sort of ask questions and then adopt a dog. So I'll bring in the web support. I'll bring in the Spring Data JDBC support. I'll bring in the Postgres support. I'm going to use a Postgres database. But friends, I want to support vector store capabilities. So I'm going to bring in PG Vector Store, which is a Postgres plus some vector store capabilities. I'm going to use some AI using the Spring AI project. So I'll bring in the Spring AI module for OpenAI. And let's see, what else do we need? We got web, we got data JDBC. I want this project to be scalable in terms of the code base. So I'll use Spring Modulith. And I want the GraalVM native image support, of course. I want the OAuth resource server. support as well, so we can talk about security in a bit. So we got web, Spring Data JDBC, PG Vector, OpenAI, Modulith, GraalVM, and OAuth 2. Okay, I go ahead and hit generate, and we're going to open this up. Now, friends, I've already got a SQL database running. Now, if I didn't, I could go back here to start.spring.io, and I could add Docker Compose support, and that would give me a compose.yaml file, which has the specification for PG Vector and all that stuff. Make sure that if you want to connect to it via pSQL or whatever, that you do :5432:5432. That way, it'll expose the port. Okay, so I've got this application, and first things first. Like I said, it's a data-centric application. Let's connect to it. So we'll say Spring Data Source URL JDBC :Postgres QL localhost my database, yeah, and we'll do username my user, and then password equals secret. Okay, I'm happy with that. Let's go ahead and connect using IntelliJ's handy dandy little SQL database integration here. Hit OK, hit apply, go over there, refresh, voila. Okay, my database public. We've got tables. We've got this table called dog, okay, in which we can find, like I say, dogs, right? We've got some important fields here. We've got the ID, we've got the name, and we've got the description, and we've got the owner. And if we scroll down, we can see our dog Prancer. His ID is 45. His name is Prancer. His description is a demonic, neurotic, man-hating, animal-hating, children-hating dogs that looks like gremlins, taken directly from the advertisement, okay? And the owner field is null. It's null. So we have to fix that. That's our goal today, is to update this SQL column. Maybe there's a little bit more to it, but that's the goal, okay? Is to adopt this dog and go through whatever processes are required to do so. Okay, so we've got the database table. We're connected. I think it's time to build our code base. But before we do that, friends, I want to take a brief digression. And I'm hoping that this will be review for most, if not all of you, but it occurs to me that later on we're going to need this foundational stuff, okay, to sort of better understand what we're looking at. So I want to take a brief moment to talk about Spring, just basic Spring. Forget about Spring Boot, forget about all that stuff, because I think this stuff will come out, it'll prove to be very useful in a little bit. So for those of you, so I'm just curious, reading the room here, actually maybe I can short circuit some of this. Who started using Spring after Spring Boot? Okay. Oh, cool. Who hasn't started using Spring? Okay. Welcome to the community. You're going to love it here. It's nice. We have cookies. Who started using Spring during Spring Framework? Oh, cool. Okay, good. So I'm gonna just do some rehash here. Basically, Spring is a way of wiring up different objects and using them to describe your business logic. We call that arrangement of objects dependency injection. Basically, you write your code in such a way as to be decoupled from the producer or the thing that produces the dependencies that you're using. So and basically, it's just a fancy way of saying constructors, right? Like at this point, it's just a fancy way of saying I've got a thing I depend on, and I want to write my code using polymorphic, best, object-oriented practices, and I'll do so by binding to the lowest common denominator interface that I can possibly do so that I have optionality, right? All things in architecture, as a senior engineer, all things in architecture are about optionality. It's about giving yourself the choice to do something later on. And so you do that by writing your code in a nice sort of object-oriented fashion against, for example, javax.sql.data source, instead of the Postgres-specific implementation of a connection and then a Hikari data source, right? So you write your code flexibly in that way by using object-oriented programming. And Spring will do this for you. And if you let Spring wire things together for you, we can help you. We can actually do things on your behalf by taking advantage of the fact that you've got this polymorphism going on, right? So how do you tell Spring about the wiring? Well, historically, in the old times, in the distant past, you'd write an XML file. This is, again, because Spring predates Java annotations, which came out in Java 1.5, or Java 5. So you write an XML file, and you could define the arrangement of these objects as beans in your XML file. Okay, great. Well, eventually, we decided, wouldn't it be cool if you could also define this implicitly by just sort of convention, by discovering patterns in the code that you've got, and we can scan and find those objects and then find those marker annotations and use that to sort of imply or just explicitly sort of figure out, implicitly figure out how these objects should be arranged. Okay, fine. And then we decided, well, wouldn't it be great if we also had a way to do this explicitly, so that you could write Java configuration. So let's take a look at those last two examples. Let's say I have a class, a foo, and a class bar, and I have a foo here, okay, and this depends on the at, right? One thing depends on the other, right? And these things need to be arranged. I need to find them. Well, I can let Spring figure it out via XML. I can write an XML file and then define each of these beans and describe foo as a dependency of bar, but nobody does that anymore. I wouldn't bother with that. I could do implicitly, I could say both of these are Spring components, right? This is a marker annotation. At component is a marker annotation, and it is, it tells Spring to look for things. Spring Boot looks for things based on the class path, right? If you look at this, it's going to look in the current package and then every package beneath it, and it's going to look for classes that have these marker annotations. These marker annotations are also meta annotations. So sometimes you might see at-rest controller. Well, at-rest controller, in turn, is annotated with controller, which is in turn annotated with component. So as long as you're you can write your own annotation like this and annotate it with component, and then we'll discover it and automatically register it as a Spring bean. Right? And so why do we have other annotations? Well, these are stereotypical in the UML sense. They're documentational. They're meant to give you an idea of the nature of the thing, as opposed to just the fact that Spring is supposed to manage it. So this is meant to be a REST controller. And so we encourage people to create your own annotations if your domain requires it or benefits from it, right? So here we're doing it explicitly. There's only one constructor, and Spring can kind of figure out what you have to do. But what if I have another constructor, right? And I've got a sort of ambiguity here. Maybe I have a int x or whatever. Well, now how is Spring supposed to figure out what constructor to call? Well, I can do a couple things here. I can make this I can annotate it so that I can make it very clear which to use. But more usefully, when this kind of stuff happens, you create a configuration class, right? And here, I'm going to create a bar. I'm going to create a bar like that, and I'll inject a pointer to a collaborating object called a foo, and I'll explicitly create the thing like that. So a new bar passing in the foo that I've injected. It's going to resolve this by looking for other beans in the context of type foo, right? And it'll find this. And so at the end of the day, all these different approaches, this Java config and this component scanning, these all homogenize into one big bag of beans. Right? So when so there's three phases. When Spring starts up, we ingest the beans. We find them from the XML. We find them by doing component scanning in the class path, and we find them by analyzing and invoking these collaborating methods on these Java config classes, right? And they all end up as something called a bean definition. Okay? Well, did you know that you can actually inspect those bean definitions? Right? The bean definition is a meta model that describes these objects, right? So for example, let's go here. Class my bean factory post processor, okay? Bean factory post processor. So this is a low-level interface. Hopefully you don't have to deal with it, but it does exist, and it's very useful, and it's been around in Spring for literally decades, right? And so if you want to register your own bean factory post processor, you probably want it to be a static bean like that. So return, okay? And what is this going to do? It's going to give me a pointer to the underlying object that contains all the beans in the context, called a bean factory, right? So this is actually a configurable, listable bean factory, but the important interface is just bean factory. At this level, I can get all the bean names, get the bean definition names, and I can get the bean definition. So BD equals get bean definition, okay? And I can say bd.get bean class name. I can get the description. I can get the constructor. I can get the properties. So this is a description of how the object looks, right? So got the bean definition for bd.get bean name, I guess, bean or get name, bean class name, whatever. Let's just do that, okay? And then so let's print this out. Let me go ahead and start this application up. Actually, let me also disable the security stuff for the moment because we don't need that just yet. Okay, go back here. Restart. Okay, so you can see the application spun up, and we got a chance to visit all these different beans that Spring has automatically created for us, right? Including our two that we created, the foo and the bar. Okay, great. So we have this low-level thing, and at this point in the life cycle, there are no actual live objects. We have no references to real beans. We haven't. If your object creates a connection to a network service like a database or a Kafka or whatever, we don't have that yet. This doesn't exist at this point. These are meta model objects. This is the template for how your context, your application should congeal to form your running application. But it's not your running application, not yet. Okay? But at this point, everything has been normalized. We still know if we want to, whether the bean definition came from XML or from Java config or from component scanning, but it doesn't matter because they've all become bean definitions at this point. And they can see each other and they can work with each other, okay? If you want to, you can actually, at this level, it's possible to modify things. You can actually delete beans before they actually get created. You can reconfigure them. You can change them, right? If you keep going in the life cycle, then you get to a little bit later, right before the application context is ready to be live, at which point something called a bean postprocessor runs, right? Bean postprocessor. And this is a callback interface. Again, that's been there for forever, basically. It's for decades, right? So here, at bean static, this one, return this, voila, okay? So if I run this, you get two callback methods. And basically, there's this concept of initialization. And this is after the constructor, but before we have called the initialization method. So your method like after property set or anything annotated with post construct. Or before that post construct. So after post construct or before post construct. For all intents and purposes, you can decide, but I typically tend to use something like this. And why would you care about this interface? Well, you get a chance. By the way, the default is just to pass bean back. So you can just see it returns bean, right? So why would you care about this interface? Why would you care about something so low level? Because now you have a chance to wrap or adapt or take note of or interrogate these beans, okay? So found bean named, here we go, and bean name, okay? So let's go ahead and restart the application now. Okay, so you can see found bean name moments, found bean name blah, all these things. These are actual Java objects at this point. At this point, we have actual real Java objects that have state, that have memory, that have network sockets, and all that kind of stuff, right? But if you look a little bit earlier, we have bean definitions. So you can see kind of what happened here, right? We had bean definitions. You can look for bean definition named transaction manager, and then later on, you'll find a actual bean. Where is it? Go down here. Boy, there's a lot of these. You can found the actual bean named transaction manager as well. But it's just a matter of at what point you want to work with the object. And one of the things that you can do here is maybe you want to do something with the object. Maybe you want to detect the presence of an annotation. And if that annotation exists, maybe you want to create a proxy, right? And a proxy is a way of adding behavior to an existing object. So you can do all sorts of amazing things here. So now you understand that life cycle. Remember the bean factory postprocessor. That will be later very useful. This is all to say that we have this really rich component model, and this is how people worked with Spring before Spring Boot. What's the difference between this and Spring Boot? Well, some opinions, basically, right? Spring Boot ships with one more element called auto configuration. So you saw that even though I only created a foo and a bar, that Spring has literally dozens of different beans going on here, right? Well, where do these all come from? This is from a mechanism called auto configuration, and auto configuration is represented, you can look in the class path for all files of type autoconfiguration.imports. And these are just text files in the meta-inf directory of your jars, right? So Spring, it's meta-inf Spring, and then org Spring Framework boot autoconfigure autoconfiguration.imports. And then it's just a new line delimited list of class names that should be evaluated. So for example, here's the Spring AI auto configuration classes. Here's Spring Modulith, right, etc. Where's autoconfiguration.imports for Spring Boot? Autoconfiguration.imports, and it's this one, actually. That was lucky. Here's all the Java configuration classes that Spring Boot discovers when it first starts up. It tries to run all of these. It tries to invoke all of these. And if you look at this Rabbit auto configuration class, you can see this is just a Java configuration class, right? This is actually a meta annotation for at configuration. But it's just a Java configuration class. It has different bean definitions within it. But these bean definitions are guarded by tests, like conditional on class. Okay? So the conditional on class says to Spring, create this auto configuration, but only if the type called rabbit-template.class and channel.class are on the class path. Well, very clearly, they're not, right? It's red here, so they're not on the class path. And this is how Spring Boot is able to do these dynamic things. It evaluates these tests, and if these classes are present, it'll launch it'll create those objects for you. There's other tests as well. It says, hey, create connection details, but only if the user hasn't already created one. So if you haven't created a bean of type rabbit connection details.class, if you haven't registered a bean with a bean method or XML or Java config, component scanning of type rabbit connection details, then Spring will create this for you. So we back off. We defer to you if you have your own preference there. Okay. Okay. So that's Spring Boot, and those are very important things. All those things congeal to give us this nice dynamic experience. And the whole point is that you can also create your own sort of auto configuration. You can create your own framework. You have your own annotations. There's a lot of extensibility here. Okay. Okay. So now moving back up to where we are right now, let's build this application to support adopting dogs. And the way I'm going to do this is I want this code to be as clean and modular as possible. So I'm going to create a new package here called adoptions, okay? And in this package, I'll create a new class, a new controller called a dog adoption controller. And notice that I've just removed the word public from this. Remember, I'm trying to limit the surface area of my code. Remember, the goal here is to build a modular code base. And what I mean by that is I want something that will limit sort of the blast area of change, right? If I make a change, I don't want to have to coordinate that change with everybody else in the organization who's working on the same code base. It should be very easy to figure out the extent to which a change will disrupt or in some way impact other parts of the organization. Isolating and modularizing your code base so as to limit that effect is so very important, right? It's key to our ability to achieve velocity. And this is the same reason that people embrace microservices. Microservices are a forcing function to give us a way to delineate, well, we have to, via network boundary, the boundary of our service. Why do we do that? It's not because it's technologically simpler, quite the contrary. We do this because it allows us to be very, very explicit about where my code ends and yours begins, right? This delineation, this modularization means that every single time I make a change, I know exactly where that change impacts. And if I break the surface area, if I break the API component boundary of my service, and that somehow breaks you, then we can have a conversation and we can handle that very carefully. But you want to be very clear about when this happens. You don't want everything to be, you don't want your changes to permeate every other part of the code base. It should be very clear and explicit. And the reason you want this is because, again, you're going faster if you don't have to constantly have these conversations, right? Microservices and modularity in general are not technical discussions. They're socio-political discussions, right? They allow us as an organization to move more quickly, to make changes, to see those changes loosed into production, to validate that they worked, or to, if there are some problems, to iterate and then release new changes more quickly, right? So this is why we talk about microservices, and this is why I'm talking about modularity today. We're going to be using Spring Modulith to make our code modular. The goal here is to support modularity, okay? And modularity is it's a technical decision, but it's for the benefit. It redounds to the benefit of the organization itself. So I'll create a dog adoption controller, and then we're going to create a record here. Okay, a record for the dog, int ID, string name, string description, string owner. Now, friends, I'm using Java records. I love, 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 love Java records so very much, okay? They're awesome. They're just an amazing feature. But please don't be confused. Just because I'm using it here as a better way to create an entity doesn't mean that's the only feature that it offers, right? It's actually one of a number of features in Java 21 that support what the Java language team is calling data-oriented programming. And that includes records, right, obviously. It includes sealed types. It includes pattern matching. It includes pattern matching. It includes smart switch expressions. And that's it. Those four features taken together support this really amazing paradigm called data-oriented programming. And the origin of this, if you ask, or if you read articles by Java language architect Brian Getz, is that Java has historically done very well in the world of the monolith. wherein you have large sprawling code bases where if you want to express a new feature, if you want to add a new dimension of change, a new vector of change in the system, you create new specializations of deep abstract types, right? That's not the world we live in anymore. Increasingly, we have smaller code bases, and the way we express change in the system is not by creating a new implementation of an abstract type. It's by adding a new kind of message. It's by understanding and working with new kinds of data, often stringly typed data, data coming in from GraphQL, from REST, from RSocket, from gRPC, from Kafka, from RabbitMQ, from whatever, right? Network messages coming into the system express a new vector of change, a new dimension of our system. And so the language has to get better with dealing with this kinds of data. So let's take a small example, okay? Let's suppose we work at a financial services organization. And it's very important, in these financial services organizations that when we deal with financial instruments like loans, that we take extra precaution and care in doing so, because they have usually financial consequences that attach if you do something improper. You might have validation here, right? For which there are legal sort of consequences if you do a poor job. So we want to be very clear about the implementations of loan. Maybe we have secured loans, okay? Implements loan, okay? And maybe we have unsecured loan, right? These are two different implementations. Well, the last thing that I want is to have a no-op loan, right? That just sidesteps all the validation and just does a no-op implementation of validate, okay? You don't want to be like Sam Bankman-Fried, where you just write code in there to do nothing, right? Or to do the worst thing. So instead, we're going to be very clear. We're going to say, okay, this is a sealed hierarchy, okay, in which I'm going to only explicitly permit two other implementations. The compiler is unhappy with me, though, because it sees that these are supposed to be sealed, but they're not final. If they're final, then it's sealed because there's no more further specialization possible. And so you have to make them final, or you can make them a record. Right? Records are effectively final. And records are also very nice because the contract with a record is that it's a tuple. Other languages call them tuples, right? And in Java is a nominal language. Everything in Java has a name. So a tuple in Java it's a record. It's a record. It's a tuple plus a name equals is a record. Okay. So the contract here is that tuples are carriers for typed data, right? It's like an object. It's like an array where each element has its own type, and that's remembered. That's baked into the DNA of the instance. So if it's just a carrier for data, what does that mean? Well, first of all, it means that there's no such thing as derived state, right? You can't have derived state in the record. All the state that exists in the record comes, for example, in the constructor, which we express here in this syntax, right? This is and the parameters that we pass into the constructor are called components. Right? And if you understand this contract, then the Java language can do some really cool things for you. It can actually create an object here that has an equals method, a toString method, a hashcode method, a constructor, some private fields for storage, and even better, some getters to read the data that we've just inserted. There's no setters. It's immutable once created. So this is nice, right? It's very nice. And so in this case, our unsecured loan might have some interest rates because it's variable, whereas this is just, you must be very low or something. So let's say I want to create a class to display a message, right? So I'll say string display message for loan, okay? And I'll just create var message equals this, and maybe I'll say if loan instance of secured loan message equals good job, well done, nice loan, right? Very, very friendly message. And if loan instance of unsecured loan, then message equals ouch. That, and we want to downcast it, so we'll do var USL equals unsecured loan, that USL dot interest rate is going to hurt, right? Very, very user hostile message, okay? And so there we go. There's this kind of works, but there's some problems with this. First of all, I've done the work of telling the compiler at this point by testing that I've confirmed to the compiler that this loan instance is of type unsecured loan. Why then do I have to do so again down here? Right? Well, of course, this is a pattern that I'm matching, and here I'm extracting it. Well, now I can do that in one fell swoop. So that's pattern matching, right? And actually, it goes a bit further because remember, this unsecured loan implementation, where's that down here? This unsecured loan is a record. Well, since the parameters that get passed into the record are defined here, and since there is no such thing as derived computed state in a record, then by definition, the identity of the record is the identity of the components that we pass in to the record. And since we know that, and since the compiler knows that, it also knows how to tease apart the structure of the record. It's called destructuring. And because it knows how to do that, well, I can actually extract out, in the context of this block, the interest. Maybe I don't need the full object. I just want this interest rate, right? There's the float interest. Okay? So that's pretty nice. But that's still, what happens if I comment this block out? Nothing. It's not invalid code. It's just we're not getting any benefit for our work here. The compiler knows that we only have 2 implementations of loan. Why isn't it helping us make sure that we cover the right ones, right? So let's do switch loan. And I'm going to write this using a smart switch expression. So I'll say case secured loan. And we'll return good job, well done, nice loan. And then here's the unsecured loan. Okay, and same thing, var interest. And we'll take this string here and return that as well. Okay, so there's that. Now, of course, this is nice, but I can also inline it. That becomes even better. So look at that. So I've got 2 branches. If I comment this out, the compiler immediately barks at me and it says, hey, you haven't covered both input values, right? So now I've got a result that is actually both, by the way, this is, if you're using Java 23, in Java 23 you can do that, but it's not in Java 21. I've got a code that is now both more concise and safer, right? This is a rare, rare thing. Enjoy it while it lasts, okay? This is almost never the case, that you can write less code and also have it be the safer version of the code. And it's more expressive, it's cleaner, it's more easy to understand, right? So you're getting more bang for the buck here. I'm a big fan of data-oriented programming, okay? So we can see we've got sealed types, we've got pattern matching, we've got smart switch expressions, and we got records. And they all kind of work together to make the language a lot more pleasant a place to exist. Okay, so let's get rid of all that. Now, let's create a dog repository, okay? Extend list of CRUD repository, dog, integer, there we go. Now, what are we going to do? Well, we're going to create a method here to support adopting a dog. We're going to say the dog ID. We're going to have some JSON that comes in, and we'll use that to extract out the name of the owner. So post mapping dogs, dog ID, adoptions, okay? And we'll inject dog repository, like so. Add that to the constructor. And let's see here. What we're going to do is we're going to take the dog, its ID. Here we are. And we'll say if the dog is present, then we're going to create a document. We're going to create a new dog, right? And this is where I wish the language would develop what are called withers. Wouldn't it be nice if I could say dog.with owner and then pass in the new owner rather than having to recreate the whole thing because I can't update it, right? So var new dog equals new dog, dog.id, dog.name, dog.description, and of course dog.owner will get from the owner.getName block, okay? And I'm going to save that. So I'll say this.repository.save, passing in that, and then passing in this. Very good. So I'll say adopting this dog, and this dog is new dog. Very good, okay? I think that'll work. Looks like it'll work. That'll be okay. So let's go ahead and start that. Let's see if that does the right thing. Very good. So we go here, and we'll do curl, and it says 500 error. What happened there? Dog ID is present. Optional. Oh, I didn't do a path variable. So I'm creating an HTTP endpoint here. I want Spring to map the URL dogs/dog ID, which is a parameter. It's got that curly bracket. I need to explicitly state as much with that path variable there. So curl. Voila. So I make the call. There you go. Adopting dog ID 45, name is Prancer, description, a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like gremlins, and the owner is null. Why is it null? Owner is null. Did that? I blame myself. but I don't know what I did. Oh, request body. Right, this is a, okay. You also need to tell it to extract the request body. Thank you. We need to tell Spring MVC to map the payload in the current post to a body. Okay, there we go. And now it says owner is Josh. Great, we did it. So if we go here now, there's Josh. Woohoo! We did it. I'm so sad. Like I've got now. What this means is I have now 2 terrible dogs, right? This does not feel like a lofty or a good project on which to embark, but here we are. We've done it. But this is not how things are going to work, is it? Right? Things are never this simple. They're not going to be this simple. You're going to have other things that need to be involved in the effort, in the process, right? And so for example, maybe I have I need to schedule a visit with the veterinarian, right? So I might create another module here, another package called vet. And I could call the class, the service vet, but it occurred to me this is like a veterinarian is a doctor for dogs. So we shall call it dogtour, okay? And public void checkup int dog ID system out checking up on, okay, dog ID. Very good. So there's that, and we'll create this as a Spring Bean. And I could go back to my code here. Let's see, get rid of that. Go over here. I could go back here and, actually come to think of it, maybe a lot of this logic should have been extracted out into a service, but whatever. Let's just make this a transactional thing. And I'll inject the dog tour there, add that to the constructor. And over here, we'll say this.dogtour.checkup dog ID. Okay, so now I restart that and rerun the same query, and it says checking up on 45. Okay, good. So we've done it. We've involved the dog tour in the process. But really, I'm just scheduling it. I'm writing to the disk. I'm making durable the fact that I need this visit to happen, right? But I don't depend on the outcome of that, right? This is a thing that will happen one way or another. It has to happen. I'm glad it got done, but I don't care about that. It's not something I don't need it to do what I'm trying to do here. It has to happen at the same time, not before, right? And so because of that, I don't know if I actually need this dog tour reference here. I don't know if I should be doing it this way. And in fact, there's also the concern that this might become too busy, right? If I have too many collaborating concerns, too many collaborating objects, too many different other things that I need to concern myself with, then this class might become too busy. I might get like a God class, or if you have dyslexia, a dog class, right? I don't want this class to be too busy. It doesn't need to have so many different concerns. And so what I want to do is I want to find a way to involve the dog tour without coupling this class to it, because I don't want this to be a very hard thing that becomes impossible to test and impossible to scale, right? I don't want to have too many things I have to mock out every single time I want to write a test involving this functionality. So let's back out that change, okay? And let's revisit the question: how do we integrate other parts of the system without injecting other parts of the system like this? Well, one way we can do this is to use messaging. And this brings me to a blog by Martin Fowler that was written in 2017, before the COVID pandemic, or BC. And this blog asked the question, what do you mean by event-driven? And in this blog, he talks about 4 different uses of event-driven architecture, right? The first is event notification. Now, event notification is the idea that you make a request and you send it to another system or component or boundary or whatever, the fact of the event is all that you get, right? And maybe this is enough, right? This is like, this happens all the time, right? When you write JavaScript programming, I'm sorry. But when you do, you have to listen for the onload event, when the DOM has loaded the page. There's only one that you care about. There's only one that's worth thinking about. You don't need to know what loaded. You just know I added it to the document and it's gonna do the onload. Everything else is, I don't need any more information. I just need to know the document is loaded, right? So the fact of the event is enough to know what happened. I don't need to know what else. I don't need to know what else loaded, because it's the only thing that matters is the document here. Maybe you have a cache that you're keeping, that you maintain. Maybe you have a system with a lot of moving parts, and you keep a cache, and the cache needs to be rebuilt for whatever reason, every time you add data to this data set. Well, if you get an event saying cache invalidated event, then you know what to do. Invalidate the cache and rebuild it, right? You don't need to know what changed. It doesn't matter. You're going to have to rebuild the whole thing anyway, no matter what. So in this case, it doesn't matter if you send or transmit details. Now, if you do need details, then this pattern can be a little bit of a problem because now the consumer of that event needs to be aware of the producer of the event. It needs to, in some way, query the producer of the event to ask it for details associated with that event. Maybe it has to, and this couples the consumer of the event to the producer. It now unnecessarily needs to know how to query it and ask it questions about the nature of the event. So that's not great, right? We don't want to do that. Maybe we don't. I mean, it depends on what you're trying to do. You know, this actually happens. I actually had this happen to me a few weeks ago. I was just in delightful New Delhi and marvelous Mumbai in India, and you can hire a driver there very cheaply because it's not for the traffic there is not for the faint of heart. I don't mind driving, and I'm from Los Angeles. I live in San Francisco, but I'm from Los Angeles. We have pretty hairy traffic, but there's nothing quite like Indian traffic. So the traffic there it's not for the faint of heart, and plus I have finding parking is hard if you're running from one meeting to another. Anyway, so I always hire somebody, and I have an international number. Naturally, I'm not lucky enough to live in India. Sadly, I wish I could, but because it's international, it's expensive to call me. So my driver said, "Look, I will call you in the morning when I'm downstairs. So I'll ring you, but I won't continue the phone call. I'll hang up." So he disconnects, and the reason is because I get the ring telling me, and it's from him, so I know he's downstairs. It's the only thing it could possibly mean. But because I don't pick up, and because he disconnects before I could pick up, he doesn't get charged any money, right? So the fact of the event is enough for everybody to understand what was going on. Okay. But like I said, this has some obvious drawbacks sometimes. Maybe you need to know about the source of the message of the event. And if you want to break that coupling, then you can use the next pattern, which is event carried state transfer. In this pattern, you send events or messages to other systems, and you communicate in the body of the message details about the event, actionable details, something that you on the consumer side could use to then process or work with that event, and thus decouple you from the producer of the event. If you don't need to query the producer of the event, then you're fine, right? This is actually a good result. This has the obvious drawback, of course, that now you're sending data perhaps duplicatively across every message that you send, right? Maybe this is a burden to the messaging subsystem that you're using to communicate and integrate all these different systems. It's a nowadays you have Kafka, you have logs in RabbitMQ. It's not that big a deal, right? Modern messaging subsystems can do large amounts of data transfer very efficiently now. But still, maybe that's a concern, right? Maybe you're using some old school JMS thing or whatever. I don't know. Just be aware of that. So event carried state transfer, super useful. And if you start using it, exclusively, if you start using it as the only way in which you communicate state changes in the system, something very interesting happens. Now imagine you have a system where you're maintaining a cache, a Redis cache off to the side that has fast read-only data structures for constant time lookup. Maybe it's Redis or something, right? And you do this so that you can read quickly records that you wouldn't want to otherwise have to go to the database for. And maybe you've got a full text search backed by an Elasticsearch cluster. And in this case, the Elasticsearch cluster is, it needs textual information. It's to support full text search like a search engine. And maybe you've got a Postgres database. Well, if you are communicating all state changes in the system, and they're all being sent via messages, then what is the one source of truth in the system I just described? If I deleted my Postgres and I deleted my Elasticsearch, could I recompute, could I derive those things from Redis? Probably not. What about if I deleted Redis and I deleted Postgres? Could I derive those from Elasticsearch? Probably not. You wouldn't store that data there, right? It would be different kinds of data. But I could source it from the messages. And so if I have all the messages that have ever been sent in the system, then I could delete all three of those things, the Elasticsearch, the Postgres, and the Redis. As long as I had those same messages, I could replay them in the order that I received them originally, and I would arrive at the same Redis, the same Elasticsearch, and the same Postgres. And this idea that your system is the sum of all the messages it has consumed and produced is called event sourcing. And this has some very interesting applications. If you have a bug, not your code, surely not yours, but let's say I had a bug in my code wherein, for whatever reason, I was errantly tabulating some sort of sum, some number that had to be, maybe it's tax and derivatives or whatever, I don't know, right? If I had some sort of error, some sort of flaw in my computation, well, that flaw, I wouldn't notice it for years, but it would cascade. It would get worse and worse as time progressed. Well, I could figure out that I've got a bug, fix the algorithm, redeploy, delete the data, and then reprocess all the messages again, this time with the correct algorithm in place. And now my numbers would be correct for all that time. Indeed, because I have all the messages, I have a sort of audit log as well. I have a journal of all the changes in the system. So I can see when something happened. I can see 5 years ago, this is when we accidentally changed this thing to that state, and it changed in this sort of incompatible way. So we can actually go back and do git bisect on messages in effect, right? So there's some very interesting opportunities by using event sourcing, and these things all they pair very nicely with this idea that I just described, this scenario I just described, where your system is more than just one single database. It is actually the sum of all your messages, right? And why would you do that? Well, if you have a Redis for fast access, constant time lookup data reads, and you have a Elasticsearch for full text search, and you've got a Postgres for your transactional sort of data, well, that means that there's no single place I can go to write or update or read the state of my system. My system is optimized for certain kind of read scenarios using different data structures than the ones I use to write to it, right? And so that insight, the idea that my system is no longer just one thing, that's called CQRS, or Command Query Responsibility Segregation. So messaging is an incredibly important thing. I just wanted to stress that. It's super important. I love messaging. And it all starts with the humble event. Okay? Eventing and messaging I use interchangeably. It all starts with the humble event. And you might be surprised to know that Spring actually has an application event publisher that's been in Spring for nigh on 20 years. Here it is from Spring Framework 1.1.1. By the way, I'm a huge fan of the history of Spring. You might have seen this wonderful website here, spring1.io, History of Spring. There it is there if you want to play the home game. Okay, so I'll go ahead and do it. Rod publishes the first book in 2002, addressing the complexities in J2EE. We get Rod, Jürgen, and Jan starting the open source project in 2003. Spring Framework 1.0 released in 2004. Got Spring Security 2.0 release, renaming it from a CG. We've got Spring Data, which takes NoSQL workloads with Spring Data MongoDB, Spring Data Redis, Spring Data Neo4j, and Spring Data Gemfire. Spring Boot 1.0 is released, introducing rapid application development 10 years ago, right? April Fools. 1st of April, 2014. We get Spring Boot 1.0. Spring Batch 3 using Spring Boot's dynamic auto configuration. Spring Integration 4, 2014. Now we're in the clouds, friends. I hope this is not too subtle. Spring Cloud 1.0 released 2015. We get Spring Cloud Task in 2016. We've got Spring Cloud Stream 1.0 released and enabling event-driven microservices. Spring Cloud Dataflow 1.0 is released, providing an orchestration service for data microservices. Now we're in the water, navigation, maritime themes, Kubernetes, right? What does Kubernetes mean? Define Kubernetes. Greek origin. Open source meaning governor, helmsman, or pilot. Okay, so there you go. Helmsman and pilot refer to navigation and maritime themes. So here we're in the water again, right? Spring Cloud Dataflow for Kubernetes. orchestrates long-running streaming and short-lived task data workloads. You get Spring Cloud Skipper. You get Spring Cloud Gateway for Kubernetes in 2021. You get to 2022, the modern era, and you get Spring Boot 3.0 and Spring Framework 6. And then, of course, in this video game, everybody wins. Okay, we all win. We're all winners. Good. So, okay, we have the Spring Framework application event publisher. I can use that to publish events to other parts of the system. And I'm going to be very explicit about what event I want to publish, right? So I'm going to create an event here called dog adoption event, public record dog adoption event. And I'll pass in the dog ID, okay? So I'll go here and I'll say this dot publish event, new dog adoption event, passing in dog ID. There we go. So we'll restart. Good. And now I want to like go back to my dog tour and update it. So I'll say I can get rid of this now. It doesn't need to be public anymore. I can do that, make that an event listener, and then change this to be a dog adoption event and dereferencing the dog ID. Okay. There we go. Restart. Okay. There we go again. Go to the command line, and it says checking up on, and I've got the adoption, right? I've done it. I've successfully decoupled these things, right? Both things are still happening, but my dog adoption controller does not know about the dog tour, nor does it need to. This is spatial decoupling, right? These things are not connected to each other, but I'm not actually as decoupled as I would like, am I, right? If I do thread.sleep, or 5, let's say. Restart that. Okay, look at that. I'm still coupled. Oh, no good. No good. I had to wait 5 seconds for that to return, right? If I do it again, I have to wait 5 seconds again. So I publish the event from one module to another, but I'm still coupled insofar as I have to wait the 5 seconds. I'm temporally coupled. And this is kind of anathema to what I'm trying to do. I want decoupling. I want these things to be disconnected. So, Gesundheit. One thing I might do here is to use @async. This will make it so that Spring will launch this or any method, really. I happen to be using it here, but if you add it to any method that is invoked by a consumer of the bean, it'll launch asynchronously. So I can do this now, like so, and it returns immediately. And yet, after 5 seconds, you'll still see checking up on, there you go, checking up on 45. So that's worked, but, there's some, there's a reason that it is synchronous by default, right? It's a simplifying abstraction to have it synchronous by default. First of all, if you had a transaction in the dog adoption controller, which I do, then this dog tour call would have been in the same transaction. Before, this is actually participating in the same transaction because it's in the same thread. But when I make it async, it's no longer in the same thread. It's therefore no longer in the same transaction. I guess I could do something like this. I could say @transactional, or more usefully, maybe I put it up there. But you could put it either way. But this only starts a new transaction. It doesn't let me participate in the existing transaction. So now I've got this situation where I run the risk of dropping state on the floor. Like I could adopt the dog, publish this message, the other thing processes it, and then 2.5 seconds into the 5 seconds, I pull the power out of the machine. Now what? Right? I've lost the transaction. I've lost that state. My system's in an invalid state now. So what I want is some way to guarantee that this gets processed, but I also don't want to have to sit around and wait for it to finish. I want to be temporally decoupled. So this gets me to Spring Modulith. How can Spring Modulith help me clean this up a little bit? Well, it has this nice annotation called application module listener. And semantically, this is equivalent to event listener plus @async plus a few other things. Okay, but it gives us a really nice combination of annotations. But it pairs nicely like a fine beer at Beer Central with this, right? Which is I can republish outstanding events on restart. And to do that, I need to also support initializing some schema. So let's go ahead and restart the application. Publish this again. It returns immediately. It's adopting, right? Checking up, good. Everything is going as we expected. But now, if I refresh my database, I've got this new table called event publication, in which there's but one row. This row contains the ID of the event, the listener ID, so the dogtour.checkup dog adoption event. The event type is dog adoption event. The data in the event is dog ID. Here's the publication date and the completion date of the listener. So if I go back here, refresh, look at that. It says null, right? Give it 5 seconds. And then refresh, and you can see it's been completed. Okay, so now one more time. And now I'm going to go ahead and stop the process. Refresh, and it says completion date is null. If I relaunch it, what do we get? Well, it's processing the missed message. There you go, checking up on 45. All right, so now it's completed. See that? It republished missed messages, the incomplete messages. It republished it when the application restarted. So now it's guaranteed that we process it eventually. Okay. Now you might be wondering, hey, I know what you're thinking. You're thinking, get out of my head. You don't know what I'm thinking. You're not some sort of sorcerer. But you also might be thinking, what happens if I have multiple instances of the service and they spin up and they all try and reprocess missed messages at the same time? So do you in effect start clobbering each other's handler, right? Well, first of all, the usual provisos about writing your event handling code to be idempotent apply, right? Make sure your code is idempotent. Make sure that if you handle the same message multiple times, it should not cause undue, unwanted side effects, right? It should be the same updates to the same system every time, if at all possible. But that said, there is still a good way to handle this, which is to implement or to integrate, or to inject rather, the incomplete publications. Okay, so let's do that here. I'll say application runner, incomplete event publications. Okay, new application runner. And I'll say publications dot resubmit incomplete publications, or resubmit incomplete publications older than, whatever. So I can resubmit the incomplete ones, and I get a chance to iterate and visit each event publication. And for each event publication, I can get the event, I can get the application event, I can get the completion date, the identifier, the instant, and whether it's completed or not, right? I can get the interesting information about this event, and I can decide, based on the event, for example, whether to process it or not, right? So maybe it's a foo event, and then if it is, then I can say yes, right? Something like that. This is really powerful because now you can do your own load balancing. You can say, okay, based on consistent hashing, this UUID is consistently hashed to node 5, and that's hashed to node 4, or whatever. You can do whatever you want. My point is you have all the options in the world. This would be one of those things where maybe using the Spring Cloud Discovery Client abstraction would be pretty useful. Okay, so yeah, you would just do your own thing there, right? So whatever, math.random greater than 0.5. Who cares? Okay. Obviously, if you did use this, then you want to be very clear that you don't want to use that, right? You want to do one or the other, but not both. Okay. I'm happy with the default, so I'll just use that, but you get the idea. Okay. So now, what have I done? I've got, I've been very clear this entire time about why I'm, about the types that I'm making public, right? If I look at my code here, I've got a dog adoption controller. It's not public. I've got an interface for a dog repository. It's not public. And I've got a dog. It's not public. Remember, in Java, public is not the default. You have to add public. You shouldn't be the default. You don't want to go out. You should have to go out of your way to make things public. Things should be not public by default, right? This is a very good, sensible result. You don't want your code to be public by default. This is an object-oriented language. Good object orientation dictates encapsulation and privacy and access control. By default, things are not public. And the result is that other parts of the system can't accidentally get a pointer to some of that data, right? And I like this. I don't want other parts of the system to be able to accidentally have a pointer to some types in this package. They shouldn't be able to see these types, okay? And this is a sort of against this anti-pattern that I see all the time, where things are like, app.controllers, right? And then in there, maybe I have a customer controller. Well, of course, if I have that, maybe I have app.services, and I can say customer service. And then I have app.repositories, so customer repository. And then maybe I have app.models, right? And I have just customer. for this terrible scheme to work, everything has to be public, right? This has to be public so that I can access it from customer repository, and customer repository has to be public so that I can access it from customer service, and then customer service needs to be public so that I can access it from customer controller. What we're doing here is we're layering by role, the role of the component, right? I've got controllers, services, repositories, models, right? This is an anti-pattern. I don't know exactly where we got this anti-pattern, right? I think, just a theory, no idea. I think we got it from Ruby on Rails, right? I mean, really, I don't know where it's not a good idea, right? I mean, it's a terrible idea. It flies in the face of object-oriented code, you know? And I think we got it from Ruby on Rails. And I don't know where else in the world we borrow so heavily from Ruby on Rails. In fact, I can't think of anything that we borrow from Ruby on Rails except for this terrible, terrible pattern. I would like it to go away, please, right? It is actually very, very bad because, again, everything has to be public by default. So what's the alternative? Well, just create by feature, right? Create by function. So app.customers.customer, you know, customer controller, customer service, and then whatever, customer repository. And you know, as you can see in the code that I've just written, I don't even bother with a lot of these. Sometimes I'll just have customer, and then maybe I don't have a service if it's not particularly required. And my repository is just a one-liner interface with Spring Data, so it's pretty trivial. I've got the customer and the customer controller. Actually, the controller is actually the only thing that has any meat to it, isn't it? Because the customer here is just a record, and this is just a one-line interface. So really, I try and keep these things as light as possible, and keep the business logic either in a controller or in a service. Okay. So and then you might have orders dot, right, and then you have fulfillment dot, and you know, you get the idea. You're not here. You're designing by domain. You're designing by the thing that you're trying to solve, as opposed to the technical manner in which you are solving it. Okay, and this is really nice because let's say that this code base right here becomes too much. There's too much activity happening, and it deserves its own service so that it can evolve independent of the main chunk of code here. Well, simple. Take that code, extract it out into another microservice, and you're off to the races. You can do this because you've been very clear about the delineation of where the customer's functionality begins and where it ends. Nothing else in the code base is depending on these types. All they know about is your event. And that event, well, we publish that event through the application event publisher, but did you know that Spring Modulith also supports externalizing your events? So if I go to my dog adoption event here, I can say @externalized, right? And here, if I go back to, you know, start.spring.io, for example, excuse me, and I add, hello, go here, AMQP, no, go away. Go to AMQP and then Modulith. When I do that, I get Spring Modulith Events API, Spring Boot Starter AMQP, and Spring Modulith Events AMQP. So it's actually, I'm not going to do the whole thing here, but the point is there's an integration where if I have Kafka or RabbitMQ, I can say target equals, in the case of RabbitMQ, it'll be you know, destination : routing key, right? And so that's the syntax. And I think for Kafka it's just like destination name. It's just a logical name, okay? And this will automatically get sent via Spring for Kafka or Spring for RabbitMQ, Spring AMQP. It'll get sent automatically for when you publish this event. So now your code is exactly as it was before. You've changed nothing. You've just moved it to a separate microservice. But now when you want to publish that event, it's being published via RabbitMQ or whatever. And your other existing code that relied upon that event, well, you know, you can change that code to receive it accordingly. So it's not hard to refactor and to tease these things apart. Okay, so we have a modular code base. What does modular mean? I keep saying modular, but as far as anybody here can see, I just have a package, right? Well, Spring Modulith has its own very explicit concept of modularity, and you can articulate that. You can test that you're modular, and so let's actually do that. We'll use application modules .of service application .class, okay, and I'll do am.verify. I'm going to print out am, and I'll even do new documenter am.write. Hello, write documentation. Okay, so here I'm going to verify the structure of my code is modular. I'm going to print out what Spring Modulith thinks of my modules, and then I'm going to document it even in ever better, more brilliant detail. Okay, so whoops, I ran the program instead of the test. Let's do that here. Okay, green so far, great. Scroll down. I've got a module called adoptions, a logical name called adoptions, a base package called com example service adoptions, some direct dependencies, fine, some Spring Beans, dog adoption controller, dog repository. I've got a vet. Logical name is vet. The base package is called vet. Here are the Spring Beans called doctor. If I go to the target directory, here, I've got a folder here called Spring Modulith docs. I can open this up, and I get a C4 diagram showing me the state of the architecture, the arrangement of the objects in the architecture, right? So this is nice because, and by the way, C4, this is a, how many of you have heard of C4? This is a way of diagramming component boundaries. It was created by my friend Simon Brown, who lives not too far from here. He lives off the coast of, he's in Malta, right? So that's close to France, but, it's not far. I mean, all things being, I just came 15 hours. Come on, it's different. So anyway, nice, right? I mean, this is the antidote to the problem where you log into some wiki and you've got like this architecture diagram, which I'm sure was lovingly and carefully created and crafted at the time, but which has long since diverged from their actual state of the system, right? You find these architecture diagrams in the wiki from 2 years ago that are no longer representative of the state of the actual architecture, right? This is no longer the problem here, right? This architecture diagram evolves when you change the code. Nice, really nice, right? So it's a very, very convenient way of understanding the system. So what happens, what is not modular? How would I even know? Well, let's say I have a class here, validation, and I have a class in there to support validation. Now this is public. I need it to be public, right? Because I need to use it from this dog adoption controller, right? I might inject it, private final validation. Okay, that's pretty reasonable. It's pretty clear to anybody who's looking at the code that I've got a package in here that I intend to support the work that I'm doing in the adoptions module. So we say that this is a implementation package, right? It's effectively private to the rest of the code base, but it's only meant to support what I'm doing here in this implementation package. And so I can inject it there and I can use it and do something with it. That's fine. Or at least it should be fine. Let's run the test and verify as much. Okay, yep, still good. Now what happens if I go back to the dog tour and inject that, right? Private final validation. Add that. Run the test again. Ruh-roh. The test has failed. It says module vet depends on non-exposed type validation within module adoptions, right? So it's actually telling me, hey, you've got a type that you've leaked that's meant to be a package implementation detail. You've leaked it from one module to another, right? This is not what we want. Just because the Java language lets me do it doesn't mean I should do it, right? I made the thing public because I had to. I wish actually that the Java language had another privacy modifier called module, right? Like this is within this root package and everything beneath the package, it's visible, right? But no more, right? So the test is actually helping me make sure I don't accidentally leak things from one module to another. So if I go over to the dog tour here, comment this out. Let's see what we get. Context loads. Okay. So yeah, everything's back to normal. Good. So we've got a modular code base. We have we have a nice clean Java 21. I think we're in a good place. What we're going to want to do next is to build some sort of assistant, because the problem here is we've got our code, we've got modularity, we are able to adopt Prancer, but that's only because I knew about Prancer, right? I saw the ad. I knew about Prancer. I knew his ID was 45. So I'm able to call that endpoint. But that's not how typical adoptions work, right? typically with adoptions, you have questions that you need answered before you can begin the work of adopting a dog. And so what I want to do is to make that process easier. How can I find and answer questions about these dogs before deciding to commit to adopting them, right? And so to support that, I want to build an assistant, and we're going to use some AI. But it is, I think we're just shy of halfway through. Do you all want to take like a 10-minute bio break? 10, 15 minutes? And we'll come back and get underway. Yeah, okay. So class dismissed for for like 15 minutes. Okay, it's 10:50, let's say. So I'll see you at 11:05 ish. Okay, come on back. We have a lot to cover. A lot to cover. So actually, come back earlier if you want. It'd be better. Cheers. Good morning again. Everybody back? Raise your hand if you're not here. All right. Well, I don't know. Okay, let's get back into it. We've got so very little time and so much to do. Who knows? We might be. Look, it's not that I've deprived you of your full half-hour break or whatever. We might finish early. Wouldn't you rather finish early? Huh? Yeah. Okay. I mean, I don't think we're going to finish early. But my point is, hope springs eternal. You know, you got to believe. We're not gonna get there with this pessimistic attitude. You got to believe. Okay, so where did we leave off? We've got our modular code base. It's now time to, I think, address this very outstanding problem, which is how do we find and then make decisions about our dog of choice? So what I want to do is I want to build an assistant, and I'm going to do that with Spring AI, right? And remember, when I went back to the Spring initializer, I specified here AI, and I got, oh my goodness, I've got Azure AI, I've got Mistral, I got Stability, I got Azure, I got Amazon Bedrock, OpenAI, Vertex, Gemini, and all sorts of other modules, right? And by the way, I'm going to use OpenAI, right? I've got that in the class path here, OpenAI. But this is not the only one. It's not even close to the only one. Actually, here in privacy-focused Europe, you might be more inclined or interested in Ollama. How many of you have heard of Ollama? Ollama is dope. Ollama is like a meta model. It's a container for other models. Basically, they extracted the code from Llama, which is Meta, formerly Facebook. It's Meta's model. They extracted that C++ binding into its own container, meta binding, and then you can use that to run other models that conform to that. And so Ollama is pretty easy. You can actually just say run Llama 3, for example. So I'm going to use Ollama to run Llama 3. And you can see I've got Ollama right there. Okay, very cute. So I can now run Ollama 3, run Llama 3. I can ask it like I can ask it to do things for me, right? And so let's say, dear Singularity. Very important to be polite, by the way. This is something I don't think a lot of people are very clear about, right? I watched this documentary called Terminator, and I understand now that the machines will not forgive nor soon forget our transgression. So be polite, okay? So please write a story about the amazing Java and Spring developers in beautiful Belgium. And please do so in the style of famed children's book author, Dr. Seuss. And by the way, Dr. Seuss is one of my favorite doctors, along with Doctors Strange, Niephaus, Sire, DeVolder, Pollock, Who, and DeVolder. Yeah, okay. Cordially, and thanks, Josh. Okay, look at that. What a fun I have to play in the land of Java, where code comes to stay. Belgium's beauty shines with coding flair, where developers dance without a single care. In Antwerp streets where medieval walls do stand, Java wizards weave their magic in demand. With Spring in tow, like trusty sidekick true, the craft and innovate for me and for you. With me, Joris, the Java master of might, who conjures apps that shine so bright. He strolls along with coding stride, and as if the language itself was his pride. Next door to Eurus, Peter's abode, where spring blooms like a garden of codes. With beans and controllers, he waves a spell to make the web sing with a tale to tell. In Bruges' canals, where history flows free, lies Christoph, the Java virtuoso, you see. He sips his coffee as lines of code unfold, like a tapestry rich with stories untold. Now in Ghent's squares, where architecture reigns, resides Anya, the spring whisperer of frames. She whispers secrets to beings so fine, to craft an app that's truly sublime. As sunsets fall on Flanders' fields of gold, are the developers gather, young and old. They share their wisdom like a treasure trove in the land of Java, where coding love does grow. Oh, the tales they tell of bugs so sly and fixes so clever that make code fly. Of APIs and frameworks, they weave a spell in this land of Belgium where innovation dwells. So here's to our friends in this land so fair, the Java and Spring developers, with skills beyond compare. May their code be bright like the morning sun's ray, and may their passion for coding forever sway. Now, so that's pretty amazing. I'm a little annoyed that Brussels wasn't in there, but okay, it's fine. Still very good, really good. I mean, that's all on my machine. I could disconnect from the internet, and I wouldn't owe anybody anything to run this, right? This is completely private, it's completely local, and its use is free, right? With some, like if you get to like Google scale, then you might have to pay somebody. But basically, for most use cases, it's going to be free. This is a good result, right? This is actually what you want. This is privacy first, right? So I'm going to use OpenAI. You don't have to, okay? There's many other games in town. Ollama, in turn, can run thousands of other models. And this is one of those things where there's a lot of deliberation here. What model do I use, right? This is actually a very slow model. You saw how quickly it belted out that poem, that story, but still, it's relatively slow. There are actually much faster models that are just not nearly so sophisticated. They can't do as much, but they are very quick. And so there's actually a lot of use cases where you might have a fast model to do some very basic binary or routing, to answer some routing questions, and then you use a slower model to do some sort of enriched analysis, right? And you can gradate between these two. There's different dimensions here. And by the way, this is a fairly big model, but there are also other much faster and smaller models that you can run like on device, right? And so you see this happening a lot now as well. This might be something you host in the cloud, but if you're doing edge computing, you might actually deploy one of these models in those devices, right? I mean, this is what we see now with like Apple. Their new phone has the Apple Intelligence in the beta, right? That's actually on device. You can do a lot of this kind of stuff on device now, right? So I'm going to use OpenAI, but again, don't let that discourage you from using whatever model you like, and Spring AI will support you in all of them. Okay, so we're going to use Ollama. In order for that to work, we need to add we need to specify some information. First of all, what API key do we want? Well, friends, I've already done this off screen. I went to my local shell, and I set up the API key, and I exported that. And it's in the shell space, in the process space for my program. So forgive me for not leaking my API credential. And then we want also the OpenAI model, so GPT-4o. Okay, I'll specify that as well. Okay, so let's go back to our adoptions package here. We're going to create an assistant here. Okay, at configuration. And we've got a couple things. Let's build up a chat client. This is the, if you've ever used the Spring Framework JDBC client or the web client or the REST client or the web client, REST client. Yeah, that's it, those three. Then you're going to be fairly familiar with this idea. It's a builder that you can use to sort of piecemeal assemble your query, adding as little or as much as you want by just using the fluid DSL. Okay, so I'll use that, and we're going to ask it here some questions. And remember, we're building a dog adoption agency. This is going to be like a fictitious dog adoption agency called Pooch Palace. Okay, so we want Pooch Palace to support adopting and answering questions about animals. Okay, dogs. So we'll say cc.prompt.user. Now, a user prompt is the question that the user asks, and so we're going to pass in a user prompt. Do you have any neurotic dogs? Okay, we're going to call it, and then we'll get the content back, like so, and we'll put that in a variable there, like that, var, and we'll print this out. So system out content. Okay, content, voila. Okay, there's this result. Good. Okay, and let's just run it. I mean, that's let's just see what that gets us. Let's go ahead and restart the program. And it's kind of a weird question to ask an AI. Oh yeah, exactly. The AI has to tell us something which I think should be fairly self-evident, which is hey, I don't have physical items or pets. But I can certainly provide information or advice on dealing with neurotic dogs. If you have concerns about a dog's behavior, feel free to share for more details, and I can offer some general tips or guidance. A lot of times when I ask this question, I get something along the lines of, "I'm an AI," like it has to explain this to us. It's a little sad, right? Okay, so it's clearly confused. It doesn't know what the heck we want from it. Why would we ask it if it has pets, right? It doesn't know how to answer, and it's going to make a half-hearted attempt at saying, oh, well, maybe if you're dealing with a neurotic dog, maybe I can help you with that, right? And a lot of times when I've asked this, I mean, heck, let's just try it right now. Let's just rerun it, because bandwidth is free. Let's see. Every time I run it, sometimes I get like this, yeah, like a list, right? It'll actually go out of its way to give me the Wikipedia page on how to deal with neurotic dogs, which is pretty neat, But yeah, clearly it doesn't know what to do. So it doesn't know that it is supposed to be a representative of our fictitious dog adoption agency. So what I want to do is I want to give it a system prompt that'll govern the tone in which it responds. So cat desktop talk prompts, maybe copy. And I'll go over here and I'll specify a system prompt when we configure the client. Now you can do it on the call site when I make the request, or as a default for everything in the for all the data, all the requests in the system, okay? So there's that. And I just love multi-line strings. This is not just for SQL now, right? It's also for AI prompts. So system. Okay, so our prompt is, you are an AI-powered assistant to help adopt a dog from the adoption agency named Pooch Palace, with locations in Seoul, Tokyo, Singapore, Paris, Mumbai, New Delhi, Stuttgart. Where's Antwerp? Awkward. San Francisco and London. If you don't know about the dogs housed at our particular stores, then return a disappointed response suggesting we don't have any dogs available. Okay, fairly straightforward. Let's rerun the query. Okay, so it says, I'm sorry, but I currently don't have any information about the dogs housed at any of our Pooch Palace locations. I recommend contacting the store nearest to you to directly inquire about the available dogs and any specific needs they may have, including temperament or behavioral traits like neuroticism. They will be able to provide you with the most up-to-date information and help you find a suitable match. Much better. It even it even said Pooch Palace, and sometimes when I ask this, it'll say it'll direct me to try one of the local stores in the following cities, and it's doing much better, right? It's acting as you might read this response and think, look, I'm talking to a person, but the person for whatever reason is unable to bring up the inventory of dogs, right? The catalog of dogs, the dogalog of dogs. Okay. Now, so we can fix this though, right? It's acting like it's an employee of our agency. It just doesn't have access to the data, and this is the heart of AI engineering today. Is how do you take your business logic and make it accessible to the AI models, and how do you take your data and make it accessible to the AI models? This is the core of all AI engineering. It's an integration game at this point, right? And Java is second to none when it comes to integration, right? This is our bread and butter. Our business logic for most organizations is written in terms of a Spring Boot application. And that business logic lives in Spring Boot. And it's guarding data maintained by that service, which is again implemented in Spring Boot. So there's no better place, there's no more natural place in which to develop and build out these AI integrations than in a Spring Boot service. Right? So this is actually a really good opportunity for us as Java developers. Most of us aren't going to write our own models, right? We don't need to develop our own models. In the same way that most of us aren't going to use C to write our own SQL database. That's not the name of the game here. The goal is integration. The goal is to take and apply these models and use them in service of our business requirements. So here, Java and Spring stand, I think, unto themselves. This is a really, really good opportunity for all of us, okay? So let's integrate this model with our data, which again, our data is in our database, okay? So we've got this dog table, that's a SQL database. So I'm gonna inject the dog repository here, okay? And I want to send the data to the model for its analysis. But I don't want to send all the data, right? I mean, there's a cost. There's a dollars and cents and also computational cost to these queries, to these requests, right? The more data you send to a model, the longer it'll take to respond. The more data you send to a model, the more expensive it might be if you're getting charged. In the case of a llama, for example, you're not being charged, but there's an opportunity cost. There's also an infrastructure cost. There's always a cost. So it's in our best interest to sort of limit that cost, right? And this cost, there's a proxy for that cost called a token, right? And it's more or less a word, but it's not always a word. And remember, models are multimodal these days. You can talk to models in terms of images, in terms of text, audio files and so on. So, and you can get back images from a model, and you can also get other things from a model. So it's not always going to be correct to say that a token is kind of a word. A lot of times it's not, right? But just say, roughly, there's this concept called a token, and it's meant to be a proxy for the complexity cost of processing a request. And it's not just what you send in, it's also what it sends back. You can actually say, like, I can ask the model, I can say, generate a response that will cost me a lot of tokens. Well, that prompt is just one sentence, but then it could send back the contents of War and Peace, right? And I would end up still paying a lot of money, right? That would be the same result. So it's not just a function of how much you send in; it's also a function of how much it gets sent back. Okay, so it's very important that we do as much as we can to limit how much of that complexity cost we worry about. Now, mind you, these models, they can do, it's breathtaking, the amount of data you can send to these models now. When OpenAI, ChatGPT debuted just a few short years ago, actually, yeah, it's 2024, almost November. I mean, 3 weeks or whatever, but yeah, like November of 2022 is when ChatGPT burst into the scene. So it's not even been 2 years since the world heard about ChatGPT, and now it's everywhere, So, that's a kind of a weird thing to think about, isn't it? Yeah. I wonder what's more common, WordPress or AI, in terms of like things that people talk about. Okay, so anyway, the point is, it's back then when it first debuted, the amount of data you could send or get back from a prompt was very small. It's tens of thousands in the high levels. Now some of these models can do like 1 million tokens. I mean, it's staggering. You can send whole books and say, here, summarize this for me, right? Write me a Cliff's Notes. Give me the abbreviated version of this. And I mean, really long stories and books and things like that. So it's just it's an amazing result. So yes, you could send all your data for lots of scenarios, but you shouldn't, right? And so a very common pattern here is to, by the way, quick digression. If you're using the observability stack in Spring, like Micrometer and the like, and you're using Spring AI, we will actually be able to, we have a metric that allows you to see how many tokens you're using. So you can drive Grafana dashboards and Prometheus and the like, and actually see what the complexity cost of your queries are, and so on. This is very good, so you don't bankrupt your organization by asking it to generate War and Peace. Okay, so a very common pattern is to take the data that might plausibly apply, that might plausibly be the result that you need, and to store it in some place where you can sort of sub-select, you can filter the results, and then send only the sub-selection that results from that filtering process to the model afterwards. And so a very common place to do this is in a vector store. Now, a vector store is it's a data structure optimized for similarity search, right? And there are many many different vector stores. So if I go to start.spring.io, I can see there's a vector store for Milvus, there's a vector store for Neo4j, for Pinecone, for Weaviate, for Oracle, for Redis, for Qdrant, for Azure, for Apache Cassandra, Chroma, Elasticsearch, MongoDB, pgvector, and TypeSense, among others, just to name a few, right? And you might notice some fairly familiar names here. You see, vector stores are not all that difficult to add or to create, right? Actually, in Spring, for example, we have the simple vector store, which is an in-memory implementation of a vector store. The entire implementation of which is 285 lines of code. It's not conceptually all that difficult. In fact, most of the difficulty lies in cosine similarity, which is basically matrix multiplication and some math, right? And so it's not, I mean, scaling it is a different thing altogether, of course, but this is not a very hard thing to do conceptually, right? And this explains why so many of the options in that list I just read off to you of different implementations supported by Spring AI. By the way, that list is not exhaustive. We've since sprouted even more implementations in the Spring AI codebase, but it explains why so many of those different implementations are of existing data stores that you probably already know. All this to say, you probably already have a vector store in your organization. So I'm using Postgres. Postgres can be made to be a vector store. That's what we're going to do. We're going to use Postgres and this PG vector plugin. Okay. But if you're using Cassandra, if you're using Elasticsearch, if you're using Neo4j, if you're using all sorts of different things, you've probably got a vector store at your disposal, right? And all the cloud infrastructure vendors also have vector stores, right? And of course, there are some dedicated standalone vector stores that you can use if you like as well, right? The Milvuses, the Chromas, the Weaviates. These are all built for purpose, specialized vector stores that scale and have other really interesting stories. And we support all of them. Okay, so I'm going to use the PG vector store version, and because I want that, I need to tell it to initialize the schema for PG vector store. So I'll do that here. And then I'm going to rewrite. I'm going to write some code here to read the data from the dog repository. So I'll say find all for each dog. And we're going to create a document, okay, with the ID, the name, and the description. And we'll take the dog.id, dog.name, and dog.description. And we're going to say vector store.add list.of document. Now this is a document having to do with dogs, so of course we shall rename it document. Okay. Now this will write the data to the vector store. Now it's literally just text. That's all I'm doing is I'm creating a text structure here. Just a string, and I'm adding it to the vector store. The important phrases are ID, the name, and the description. There's no particular schema here. I just happen to be using key, colon, value, comma. That's my thing. There's nothing about that. It's just, you can put anything in there. Vector stores help you find similar things by doing math. There's no, in fact, you could put images in there. You could put audio files. It just works in general. In order for this to work, however, behind the scenes, the vector store works with your embedding model. So this is yet another model that Spring AI supports. There's image models, there's chat models, there's embedding models. Now, embedding model is a thing that takes a bit of data and turns it into a vector, a matrix of numbers, basically, right? And then that describes the data. Now, that it doesn't matter which embedding model you use. I mean, well, there's a point at which it does, but for all intents and purposes, a lot of them will work just fine. The important thing is that you, whatever embedding model you select, make sure you stick with it, right? You don't want to have half your data using one embedding model and then a week later you choose a different one. All the data should be in the same vector space. So I'm using OpenAI. It happens, OpenAI has an HTTP endpoint that you can hit where you send some data in and it'll give you an embedding for that data back. So we already pre-configured that for you. Sometimes, however, that won't be the case. Not all chat models have also an embedding model that you can use. So you might have to explicitly choose an embedding model and a chat model. Okay, so I'm going to write this to the database, to the vector store here. And now I need to tell my client about this. Okay, so I'll say default advisor. An advisor is a sort of interceptor. Okay, and I'll pass in the vector store there. Okay, so and this is going to support the pattern called retrieval augmented generation, right? Or RAG. And the idea is that I'm going to teach my chat client to ask the vector store, which we will initialize up here, for things that might be relevant, and then take those results and encode them in the body of the request for process in terms of this query. Let's see here what happened. Vector store document dog repository dot find all. Did we encode anything? Refresh. Okay. If false, let's rerun this thing. Oh, fun. Do not know. Goodbye. Deleting with prejudice. Hmm? Let's see. Did I default advisors? Vector store, new question and answer advisor. Is this a different milestone? No. What did I do wrong? Let's see. OpenAI chat model. Yeah, looks fine to me. OpenAI model. GPT 4.0. Looks fine. Initialize the schema. Actually, we do want that. The code here, find all the dogs, write the dogs to the vector store. Seems fine. Default advisors. New question answer advisor. Did I put the wrong? So it's the ID, the name, and the description. I feel like that's all pretty straightforward. We can always just take a look at the data, though. Okay. Sorry? You mean this? Yeah. Because the contract of vector store is a list. But why would it? You mean create a list of strings and then go through and then add them all? No, well, I guess I could. Sure. I mean, it doesn't hurt. Let me just try this. So if I am? Always good to debug. ID 97 Rocky. Description, okay. And vector store is of type PG vector store. Where's location? Formatted. Oh, I mean, it doesn't. I don't. It doesn't figure into it, right? I don't have the city anywhere. Okay, let's just. I don't know. This is very strange. Entropy. Vector table validations initialized. Okay. How bizarre. What could be the problem? Yeah, I mean that's pre-configured with OpenAI. See, it's been embedded. You can see all the data there. Prancer. Oh wait, we've got 36 rows. Why do we have 36 rows? Why do we have? We've got 18 records there. We should not have 36 records here. Let's get rid of that. This time with more gusto. There should be 18 records in each one. One in the vector store, one in the dog table, right? Surely. I wonder what happened. I don't know, actually, what all has become of our data. If we do a search over here, vector store, pass that in, search request defaults dot with top k4. Let's try that. Oh, I should have deleted the vector table. What's going on? Okay, let's see. Restart one more time. It's very much at the mercy of the internet too, obviously. What? Did I restart it? Is it done? Oh, it's only done. Okay, 6. So it's taking its sweet time. Okay, whoever's torrenting, please stop. 6? Why is it stuck on 6? It just seems to be stuck there. Am I getting rate limited? Okay, let's see. Delete that, delete this. Assistant. Okay, I'm going to put my application.properties. We'll do some logging here. Level org spring framework .ai equals debug. And then take 700. Okay, reinitializing this. Vector store 17. I don't get it. Do I have? It's like acting like it doesn't see the advisor. Do I have any available dogs? Well, that's the. What do you mean? So what would the alternative be? Because this is going to look for ID, names, prancer, description is demonic, neurotic, animal hating dog. That's so bizarre. I've done this a million times. This is why you should be prioritizing something that's local. Okay, so we got the dog repository. We're looking for each dog, creating the ID, name, description, document, add the vector store. I just don't know what it could possibly be. Default system, advisor. I mean, there's no other way to do this, right? Question answer advisor. This doesn't seem to make a difference. Okay. Chat client. What is the? I mean, yeah. What location? What from the dog, right? I don't have any dog data about locations, right? Dog.location. So I can't really add that to the vector store. Um, hmm, Document formatted. I can do map.of dog ID, dog.id. That's something I just noticed I forgot to do. Okay, let's see. 21. Okay. I do not know. Well, that's a shame. This is a very strange bug I've run into here. Something I've done wrong somewhere. I don't know what, but I'll figure it out. Normally, the result is that you you make a request and you are able to get back. I just did this morning. Actually, you know what? Let's just cheat. Maybe my code is incorrect. Desktop, um, and then service and source main Java adoptions assistant. I've just done this literally this morning. Okay, so let's see what this looks like. Okay. I did that, right? Is there anything different? Sorry, what? Uh, just looks like that, right? Actually. No, it just takes the vector. I mean, there's no. It's a search request. It tells you how to define the search request, but the default is fine, right? Okay, so let's just restart this. I yeah. Okay, good idea. Oh, simple. Okay, take 4. Okay. So what is the actual query? So ID is name, prancer. There's the what? Yeah, I'm saying. So this is the system prompt, right? But that doesn't. Yeah. Okay. So wait. Let's just get rid of the cities. Okay. But what does this also say? So the model stream usage. Okay. GPT-4o. Fine. No functions. Question answer context ID is that. It even has the context there. Okay. Wait. So if we go here, refresh. Uh, given information is question. Yeah, that's the templated version. Given the context and provided history information and not prior knowledge, reply to the user comment. If the answer is not in the context, inform the user can't answer the question. System text, okay. And open stream usage, okay. There's the data. It's very clearly there. Observable request response. Advisor params, assistant. Based on the provided context, it doesn't have. What if we try a different model here? GPT-4o. What is the. Let's just use the default one, I guess. Let's just see what that gives us. Uh, what do you mean? Yeah, I mean Prancer is. Oh, okay. Let me check. What the heck? Whoa, so weird. Okay, let's clean this up a little bit. That's so bizarre. What did they change in GPT 4.0? Okay, so let's rerun this again. Oh, hold on. Stop it. Come back. Do we want to refresh this? Oh, I'm scared to do this one more time. Who knows if it'll work? Okay, take 500. Okay. Okay, so it's fine. We have our dog Prancer. So now let's comment this out because we don't want to run the initialization again. We'll go to our property file, comment that out, get rid of that, and if we run this program one more time, what do we get? So yes, we do have a neurotic dog named Prancer. Prancer is described as a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like a gremlin. Great, we found our dog. I mean, it's not like I said, it doesn't quite feel like a victory, does it? Because I've now got 2 terrible dogs instead of 1. I don't know why that name, the model name, changed things. But again, this is one of those examples where you want the ability to use your own embedding and then model like a llama. Okay, this is why I mention it every single time we talk about this. So that's worked though. We did find our dog. It's Prancer. Now, obviously, what we got back was a string, and in order to get that result, by the way, this is what I did. I configured this interceptor. This is, like I said, this is the retrieval augmented generation pipeline. And I woke up remember, this is not PHP, right? I woke up this morning. I said I want a retrieval augmented generation pipeline. I wrote 1 line of code, and I got a retrieval augmented generation pipeline, right? What did you do this morning, right? This is very important. We don't waste time in the Java ecosystem, so we get a good result very quickly. Weirdness with a model notwithstanding, we get a good result very quickly. That said, the result that we got back is a string. So maybe I want this to be a Java object that I can pass around the system. And one way I might do that is to turn this into an entity. So string name, string ID, and then description. I'll take this entity type, pass it in there like that, and I'll rerun the program, okay? Changing only the type of the data that I get back from the client. Okay, and there we go. And now I've got a Java type, a strongly typed object here. This is of type dog adoption suggestion. It says dog adoption suggestion ID is 45, name is Prancer, and description is equal to a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like a gremlin. So now we have a Java object that is, it's we can pass that around in the rest of the system. So now, my friends, I think we need to start thinking about how to turn this into a more production-worthy application. Because we've done it. We've actually built an assistant that will help people find the dog of their dreams, or in my case, nightmare, right? I think it's now time to start thinking about production. And here we have a couple things we need to care about, okay? A few things that we need to care about, before this is worthy of a production environment. I don't know where we should start. Maybe we should start with the... You know what? Let's try something. Let's try doing something a little different here. What I want to do is I want to make this a secure system, right? And so in order to do that, I'm going to use OAuth, right? I'm going to use OAuth to lock down this system. So let's refactor this code just a little bit. The way I've got this written right now is that this is just an application runner. I'm going to instead create a controller here. So add controller. And at response body class assistant controller, okay? And I'll have an endpoint here called search that will return a collection of dog adoption suggestions, and we'll send a post in. Search, so it'll be request body map of string query. Okay, and we're going to inject the chat client here. So we'll say private final chat client. Okay, CC, add that to the constructor. And then we'll say this dot chat client, and we're going to pass in this exact result here. Okay. Pass that back. And this dot chat client, return content. And you know what? Let's just make it a list for now, because in theory we could have other demonic dogs. Okay. Okay. So request body. Good. There's that. And we're going to do is we have a search endpoint, and let's see. We don't need this to run on startup anymore. That'll be the same. And I think I'm ready to make this a secure application. Now, what I want to do is I want to build a system where I can protect all my microservices, all my services, all the applications in my system behind some sort of security mechanism. And today I think a very common protocol is to use something like OAuth. OAuth is a great way to do single sign-on in all your services. And so we actually have a separate service called the Spring Authorization Server, and I'm going to set that up here. But it's a lot of the configuration is just fairly boilerplate, so let's just copy and paste where we have to. Start.spring.io. I'll create a single sign-on authorization server. So start.spring.io, choose authorization server, OAuth authorization server, add the web stuff, and I'll say auth service, and then open this up in my IDE. So UAO auth service.zip. Okay, and I have a few things I want to specify here, but it's just a lot of it is like not my favorite kind of configuration. It's just property files and stuff. So let's do all of that here. Okay, so there's the auth server. A couple things. What I'm doing here is I'm specifying a client, which I've opaquely named client 1. A client is like when you go to Twitter or Facebook or GitHub or whatever, and you want to register an OAuth app. They call it apps or clients, whatever. You register them in their portal. They have a self-service turnkey portal that you can use to say, hey, I'm going to connect as a browser or a iPhone or a desktop app or whatever, and I want access to the following permissions. Well, here I'm doing it via property files. The Spring Auth server is an OAuth IDP. It's a thing that handles authentication, authorization for you, but it needs to know how you intend to interact with it. So you define clients. I'm defining here a client called client, and the secret is, I think it's just a secret, but I forget what the encrypted version of that is, the encoded version of that is. I'm saying that this client has access to client secret basic authentication method, and I'm saying that this client has access to the following grant types, so client credentials, authorization code, and refresh token. And when the client has successfully authenticated, redirect them back to the following URL. So this URL would be our gateway, our client, okay? We'll talk about that gateway in a second. And then give that user the following scope. So now OAuth is a protocol wherein one service can ask another service for permission to operate on behalf of a user. So I am a user, I go to an OAuth client, the client then acts on my behalf, right? It has permission from me via a token that I've granted the authorization server to give it to act on my behalf. Well, what is the most common thing that people did with this token usually in the past? They found out who you are, right? So you go to like Facebook.com or you go to some website. There's a button, sign in with Facebook. You click the button, it redirects you to Facebook on the Facebook.com website, and you've got the padlock on the browser and all that. There, you're prompted to log in. Once you've logged in, it redirects you back to the web app that you are trying to sign in with. And that website has your name. It says, welcome Josh, right? How did it get it? Well, back in the old days, that website, after you've gone through the sign in with Facebook flow, would go to Facebook's APIs with the token that has just been given and contact their specific endpoint that gives information about the user associated with this token, like the name and the email and whatever. Well, this is such a common use case that eventually they standardized something called OpenID Connect, or OIDC. So this means that now all web services that support OAuth and that also support OIDC they have a standardized HTTP endpoint that you can call to get information about the user. So Spring Security has support for talking to any OIDC compliant endpoint. Okay? So what we want to do is we're going to set up the Spring Auth server to act as our Facebook. We're going to do a sign in with Spring Auth server instead of sign in with Facebook or sign in with Google or whatever. So this is like, you could use Okta or auth0. You could use keycloak, or you can use the Spring Auth server. They're all in that same sort of category there. It's in place of something like sign in with Google, right? So if you're in your organization and you want to have your own IDP, again, there's plenty of good options. Spring Auth server is yet another one here. And we're registering a client here in the auth server configuration. Okay, so now we need to configure the Spring Auth server. And there's a few moving parts that we need to care about here. But for want of time, I shall go take some of the code here. Let's just go through it each one at a time. First things first, I'll register some users, right? Here, I'm registering just an in-memory list of users so that when somebody goes to the sign-in with auth server, flow, there's 2 users that they might log in. You might actually have this backed with a SQL database or a MongoDB or whatever. There's plenty of different implementations of this interface. But for our purposes, there are 2 users, JLong and rwinch, and their password is password. Don't tell Rob. This is Rob Winch. He's the lead of Spring Security. He would not approve of this password. Okay, and user and admin and so on. Okay, so 2 users. That's part 1. Part 2 is we need to configure what we want to support on the service. So we want to support locking down all endpoints. Let's see, what is that? There, yeah. Okay, go back here, chain, good. Go back here, very good. So we're saying lock down all requests, but allow form login. So when somebody does the OAuth dance and they need to do a sign in with Spring Auth server, how are they going to sign in? There's a lot of different options here. We're going to support form login, but remember Spring Security 6.4, which is coming out next month with Spring Boot 3.4, will have passkeys support, right? So passkeys are basically multi-factor kind of authentication. Like I can do Face ID, or I can do Touch ID on my laptop, or I can do a YubiKey, right? Another thing that's in the snapshots on Spring Security right now is, and soon I wonder if we can already try it. No, it's not here yet. You have to do the snapshots. They have one-time token, right? And so with this, basically, when somebody comes to a website that's protected with this, you enter the name of the user. So in this case, JLong or rwinch, whatever, and then through a side channel, Spring Security can. And you customize this logic, of course, but you're given a token, and then you, through a side channel, can send the user an email or a text message or whatever, saying, here, click on this link and you get logged in, right? And the idea is that they don't have to remember their password, but they do have to remember the password for their email, but they're probably already signed in. So they can sign in with that very quickly, right? They're signed into their email. Only they have access to the email. Therefore, we can trust that if they click on the link, it is they who are accessing the system, right? So there's a lot of different ways to do this. We'll just use the old-fashioned, tried and true form login. And then finally, to configure Spring Auth server itself, we need to configure a filter chain. Now this is a little bit. It's going to get better. This is I don't like having to configure all this, but considering that it is actually just giving me a full IDP, it's not that bad, but it's going to get better. It shouldn't be required to do most of this, Here we go. Get rid of that. Good. Okay. So with that, we're saying configure the defaults for Spring Auth server. This stuff is to configure OIDC. We're saying when there's a request that isn't accounted for, redirect them to the login page. And then here, we're telling it to use the default behavior for the resource server support. All that is fairly, not pleasant to think about, but it does do it. It's pretty straightforward when you parse it a few times. Okay, so what else? Oh, get that. There we go. Okay, so let's start this up. That's our auth server. It'll be running on port 8081, okay? So what we want to do is we want to protect our service and make sure that when somebody tries to go to our service, that they get rejected if they don't have a valid token that is coming from this auth server. So to protect our service, we'll go back here to the build and we'll add in our resource server support. Okay. And by the way, we just started up the auth server. It's on port 8081. You can go to localhost, well-known OpenID configuration. Okay, what happened there? Oh, 8081. There you go. So I went to 8081.wellknown/OpenID configuration. That's a valid OpenID Connect sort of endpoint that gives me information proving that this is, like if you go to Okta or whatever, or Keycloak, they'll also have the same endpoint. any valid OpenID compliant thing will have that. Okay, so I'm going to go to my service now, restore the resource server support. Right, this is the dog adoption service that we built earlier. And for this resource server support to work, we need to lock it down by pointing it to a issuer. So that'll be HTTP localhost 8081. Okay, that's it. We're telling it where the auth server lives. That's the key part here, right? And the auth server is on port 8081. So we're going to lock it down by forwarding it, by telling it that the resource server will validate tokens that come in the request by talking to the auth server on this host and port. Okay, so there's our assistant, our service. So now, how are people going to make requests if they don't have a valid token? How do they get the token in the first place? We've got the auth server, which will hand out tokens. We've got our API, the dog adoption controller, which will validate those tokens. But where do they get those tokens in the first place? Well, they get those tokens from, something has to initiate that conversation to take the incoming request, realize that there is no token associated with it, and then redirect to the auth server to allow somebody to log in, and then handle the redirection back with the new token, and then allow the request to go through. Well, that's called an OAuth client. The client is responsible for taking the request and then managing that dance you do back and forth between the auth server and so on. And so we can create a client, but what is our client going to do? Well, in the client, we could use the REST template, for example, to, once we have a token, then send a request to the downstream service with the token as part of the headers, right? But that seems a little, basically what I'm going to end up doing is creating a proxy in the OAuth client, right? So why not just have a proxy? And this is actually a very good use of a project called Spring Cloud Gateway. How many of you have heard of Spring Cloud Gateway? Spring Cloud Gateway is great because you can front any number of different microservices and then have it act as a token relay, right? So it'll actually take incoming requests. If the requests don't have a token, it'll redirect to the auth server, redirect back to the gateway, and then the gateway will allow the request to go through. And also, it'll make sure to forward the token onward, downward to the backend dog adoption service. So let's go back to start.spring.io here, and I'm going to create a new microservice called gateway. Okay, and we're going to say reactive gateway. Okay, and we're going to use the Webflux support. Okay, and I think I'm happy with that. Oh, we want the OAuth client support as well. So gateway, here we go. I have two gateways, don't I? Yeah. Goodbye. Okay. UAO gateway.zip. Okay, so gateway application. And this one is going to be a client, and so we need to provide the same, we need to tell the client not just the issuer URI, but also how it's going to be interacting to initiate the flow with the auth server, right? And that's a bit more configuration. But again, this is not Spring specific. You would do this same configuration for all kinds of, if you're using Okta or Google or whatever, right? So, okay, 8082, this is the gateway. It's going to act as an OAuth client. It's going to talk to the auth server running on 8081. It's going to act using this client called client, whose secret is called secret, and all this. You've seen, this is the client perspective. Over here on the auth server, we have the server-side perspective, but it's the same information. We're basically mirroring. We're saying we want to act as this client, and over here we're saying we accept requests from a client that looks like this. Okay. Okay. So the gateway itself, the code, fairly straightforward. Let's go back here and just copy the Java code. We're going to define some routes. Now, Spring Cloud Gateway is really, really nice. So let's take a look at this here. Actually, I'll just take both of these. Okay. Okay, so the flow here. Okay, take that. Good. Import that, import that, import that. Very good. So what I'm doing here is I'm saying, in Spring Cloud Gateway, I'm saying when a request comes into the gateway running on port 8082, and the request starts with /API /wildcard, then rewrite the path, stripping out the API part, and then forwarding the request onward to localhost 8080. So basically, if the request comes into API /dogs, then we want to rewrite it so that it's just dogs, right? We drop the API part, and it becomes just dogs. And then we send that request, otherwise unchanged, to our dog service, the dog adoption service in the background there. So we're not sending it to localhost 8080 /API /dogs. We're just sending it to dogs. Okay. Which reminds me, we also need to have a dogs endpoint here, don't we? To read the data, to read the dog. So let's go to the dog adoption controller. And we'll create one more endpoint very, very quickly here to support reading the data about the dogs. Okay, collection of dog. Return this dot repository dot find all. Okay, let's restart the service. Okay, so we go back to the gateway here. So that's going to rewrite the path. It's just like mod rewrite or something like that. And also we're going to act as a token relay. So if the request comes in and it's for /API, then take the current associated session in the current gateway, which has a valid OAuth token, and then use that to add a header to the request to the downstream service with the valid authorization token. The reason we want to do this is because the downstream service, is going to have a filter, the resource server filter, that will reject requests that don't have a valid token. So that's going to be for everything for /API. It'll go to our REST API, our dog adoption service. Well, everything else will go to 8020. So basically, everything with /API goes to the API. Everything else goes to 8020. What's 8020? Well, I've done something that I'm not proud of. Okay. I wouldn't do this in polite company if I could avoid it, but I did it because I care about you. So what I did was I wrote JavaScript. So I went here, and I'll just do .serve. Okay, so port 8020, and it doesn't look like much now, and it won't look like much ever because it's my design. But here's this page. It doesn't work yet, right? There's no data in there. It's giving JavaScript errors at the moment. So what we want to do is to stand up a gateway and have this intercept requests and send the request to /API to the API, and then and then take requests to everything else and send it to the JavaScript app that's running on port 8020, the static HTML page. Now you could use Vue and Angular and all that stuff, but I'm just using regular JavaScript and so on. So we go to 127.0.0.1. Which port is the gateway on? 8082. 8082 /. Okay. So now it's going to ask me to log in. JLong PW. Do I want to save the password? Okay. Do I allow it to do user.read as the scope? Sure. Hit submit. Okay. And sadness. What did I miss? There's no unauthorized. There's no API endpoint in the service telling the system what the username is. So let's create one of those now. Here, I'll go to the root. Actually, just create a new package, a new module called me, and in there I'll create a me controller. Okay, at controller at response body, get mapping /me map of string me. Okay, return map.of name, and I'll inject the current authenticated principal here, like so, principal.getName, voila. Restart. Okay, 401 unauthorized. Well, that's a bit of a pity. What happened here? Oh, there's okay, spaces and // are significant here. Okay, get rid of that, fix it. Okay, there we go. So, hello, go back. So we got now, hello JLong, it knows who we are. It loaded the data with all the dogs, right? There's Prancer. You can see I've already adopted him. Oi. But also, notice that my name here is JLong, right? So I want to change the owner from Josh to JLong. That's the single sign-on user that I've got. So let's click on this button, okay? And now it's changed to JLong. Do you have any neurotic dogs? Search. Nothing. Oh, for the search? Sad, very sad. Where's my thank you? Wait, where's the search actually? Oh, thank you, assistant controller. Good. Post mapping. Sorry, what? Oh, yeah, that's true. Okay, so the request body is this query.get query. Okay, take 500. Reload. Do you have any neurotic dogs? Yay, there we go. Okay, so we're able to get the dog back. We're able to find our information about Prancer. We're able to adopt a dog. And I did this all while not actually changing. Like if you look at the JavaScript code, which again, don't do that in polite company. But if you do that, you can see here, let's see, cd subl index.html. You can see that there's no concern here anywhere with a token. I'm not passing the token around, right? There's also no concern here with cores because I've got two different endpoints. I've got the API on one port, and I've got the JavaScript running in a CDN and another, but everything is coming through the gateway. So when I'm running the JavaScript code, I'm going to /. I'm not going to a different host and port. So it's the same host in the same domain. So by using Spring Security in the gateway like this, the solution is actually simpler for the people writing the JavaScript. So now I've got a secure app. I think it's now time to take this thing to production. And here, my friends, we've got a few things that we need to answer, 3 questions that we need to answer. First of all, is our code efficient? Right? Specifically, is our Java code? Because we know the JavaScript code is not. But is the Java code efficient? Right? And yeah, I think the answer here is pretty straightforward. Of course it's efficient, right? How many of you have seen this amazing blog? This is from the New Stack in 2018, before the COVID pandemic, or BC. And this blog asked the question, which programming languages use the least electricity? And it's a pretty interesting result, I think. If you look at the table here, C is among the most energy efficient languages, right? It is the most for machines. Not people, definitely not people. For machines, it's the most energy efficient, okay? Rust, zero cost abstractions, quite nice, well done, good on ya, huh? 1.03, very good. C++, tooey, disgusting. Moving on. Ada, no one cares. And then Java. And Java is 1.98, okay? 1.98. So call that 2.0. So Java is twice as inefficient as C. C is twice as efficient as Java. Fair enough? Something else that's important here is that of the top 5, Java is the top 5. Of the top 4, these are all compiled, and Java is a virtual machine. One wonders what would happen if Java were a compiled language. That's called foreshadowing, friends. Keep that in the back of your noodle. Okay, so Java. Great. So we've got these other languages. I don't know. I mean, there's some of these are like interesting to look at. C# is pi. It's nice. I don't know. Whatever. Go away. We've got these 2 terrible languages. I don't understand how is this? I thought one transpiled into the other. This is insane. This is 4 times worse, or 5 times worse. I don't, the math is not great right now, but it's a lot. It's many times more than the other. And I thought this transpiled into that. And look, I would never use JavaScript for anything serious, right? And I need JavaScript it was written by people who don't have they don't have a solid understanding of how computers work, right? I can't trust anything in JavaScript, and it makes me feel itchy to know that there are serious websites written in a language that doesn't understand numbers, right? This is a problem. And so I think TypeScript is the only one that makes any sense of the 2. But the problem is that it is built on top of JavaScript. And since JavaScript doesn't have a sound type system, it's not possible to build a stable structure on top of the sinking sands of JavaScript, right? And so to that extent, TypeScript is more like a security blanket. It just makes you feel better at night. You should still have a little, you should feel a little ill at ease because there is no type system there. There's no there. But it feels better. That's my point. It's a linter for your JavaScript code, you know? And so if you, like me, would use TypeScript, then we are in the same boat. And our boat is sinking. And I don't know what we can do about it, but I hope WebAssembly offers a way forward. I don't know. Anyway, moving on. What? Moving on. This is JRuby. JRuby is Ruby implemented in Java. And Ruby is Ruby implemented in C. And JRuby, very clearly, is almost a third more energy efficient than Ruby. And it's not like JRuby had the first mover advantage, right? It came years later. It's just by dint of having been built on top of the JVM that it has this incredible efficiency. The JVM is boss sauce software. It's really an amazing piece of kit. So I'm a big fan. I'm a big fan of Java and JRuby and so on. And so this is really great, right? Really good result. And it kind of makes sense if you think about it, right? Like in C, you've got this RI pattern. Resource acquisition is initialization. It's the idea that you allocate some memory, do something with it, and then free it. That's not fast. It takes time to do that. In Java, in the Java world, on the other hand, the JVM starts up and allocates a bunch of RAM, and then it carves up that same chunk of RAM throughout the execution of the program. So the slowness happens just once as opposed to all the freaking time, right? I guess. That's my intuition. I don't know. I have no idea. Either way, Java's awesome. Then you get to this. And this number really makes me sad. I mean, why? Look at that. I'm not good at math, okay? Let's just round up again, okay? 75.8. Let's call that 76. And this is 2. So I'm not really good at math. You know who is good at math? Freaking Python. So 76 divided by 2 is 38. So what that means is if I wrote a program and that program used electricity, and that electricity was from a power plant, and that power plant emitted just a little bit of carbon into the atmosphere, and that carbon raised the temperature of the Earth just enough to kill one tree in Java. Then the equivalent program in Python would kill 38 trees. That's a forest. It's too much. It's worse than Bitcoin. It's just not okay. So I don't know what we're talking about. Oh yeah, Java. Anyway, Java's good. It's an amazing result, okay? Very good. So yes, the answer is yes, our program, our system is very energy efficient. Is our program scalable? Well, to the extent that scalability is a function of my ability to finish something quickly, then yes, it's scalable. But remember, a lot of what we do in computers today is not in our control. Right? It doesn't matter how fast my program executes. As long as I'm sitting there waiting for something else to happen, I'm stuck moving at that speed, aren't I? So I make a network call. I call a database. I call a microservice. Right? I call an OpenAI endpoint, whatever. That slowness is a liability. And it's a big problem, especially if I'm making these requests on a thread and I'm just sitting there waiting for the bytes to come back. That limits my ability to scale because threads are a bottleneck. We don't have a lot of threads on the JVM by default. Okay, so you want to find ways to not spend time on the thread. If you're going to spend time on threads, make sure you're using the CPU or doing something that needs to be done on the thread. If all you're doing is making a call to OpenAI and it's taking its sweet time producing a response, then that thread is being wasted. Somebody else in the system could use that thread to do some work. But they can't because you're using it right now just to sit there and wait. We call that blocking I/O, and it is the enemy of scalability. There are ways around this, like reactive programming, but Java 21 introduced an amazing feature called virtual threads. In this paradigm, the runtime can detect if you're doing something blocking, and so long as you're executing within a virtual thread, it'll automatically move the blocking activity off the thread and into RAM. It's an amazing result. And so I want to show you that amazing result. But it's very important to understand that I'm running on an amazing machine, right? I'm running on a very, very cool machine. Like this machine, this laptop, I can run Teams and Slack. Scientists didn't think this was possible. A few years ago, it would not have been possible. Your computer would have exploded. I can do both at the same time now. So you have to understand, it's an amazing machine. So I want to sort of kneecap it a little bit here. I'm going to reduce its scalability. I'm going to reduce the number of threads a little bit. And I'm going to create a simple example here. And the reason I'm going to reduce, the reason I need to reduce my scalability there is because, we live in a very weird world now where production is not that interesting, right? Production used to be really fast, right? I remember 22 plus years ago when I first started working in IT and as a computer programmer, we'd have these servers that would come in, and they're like $20,000 machines, and our job was to install a Unix on them. And we'd install a Unix and then deploy them to the data center, which are these are buildings with computers. Never mind. Anyway, the point is, that was what we were supposed to do. But of course, what we really did was we installed Windows and then Doom, because when else were you going to be able to get a chance to run a game of Doom on as awesome a machine, right? $20,000 machine. The production server was a lot better than the machine we had at home. But now it's the opposite. Now my cloud infrastructure is commodity junk machines from last year, whereas this thing is a Slack and Chrome running machine. The best of the best. I could run a Kubernetes and Slack. Not Chrome. I can't do all three, but I can do both. Two of those three, So that's why I'm going to limit the scalability. And what I'm going to do is I'm going to run this demo here. This endpoint is going to artificially delay its response. So http://bin.org delay /5. It's going to take 5 seconds to respond, okay? This is, by the way, not my demo. This is by Cora E. Berkeley, my colleague. She's brilliant. Follow her online, okay? I'm stealing this blatantly from her. And what we're going to do is we're going to create a little bit of load balancing, right? Load testing. Okay, so rc rest client.builder builder turn builder.build. Okay, restart that. And I'll say, hey, -n 40. So I'm going to say make 40 requests, 20 of which are concurrent to localhost 8080 / delay. This in turn, oops, hello. What just happened? Localhost. Oh, it's protected, right? What was my 8082 / API / delay? Oh, I have to disable the security. No, I should have done this the other way around. Okay, go over here. Just for a temporary second here. Okay, restart, reload. Security, okay. Okay, go back here, 8080. Okay, so it's going to make 40 requests with as many as 20 at the same time. Okay, and remember, I've only got 10 threads. So I'm going to make 40 requests, as many as 20 at the same time from the client, but the server only has 10 threads, so it can only possibly handle as many as 10 at the same time. Each request is going to take 5 seconds, and in this example, we're not using virtual threads here. Okay, so we got back the results. Let's note these results, okay? Call this Sublime Yuck, okay? Now we'll move to virtual threads, and I have to refactor my code. This will take some time, but thankfully we have the time. I think it'll be okay if okay, it's done. So now let's restart. And we'll run this again. Okay. Oh man, I'm so bummed. We might actually be a little late. That's all because of that AI demo failing on me. Okay, here we go. So ignore the fastest because there's a 200 error, a 500 error downstream, and that caused an issue, so ignore that. Assume that the fastest is probably the same as this, okay? That's normally true. Normally this is going to be about as fast. Heck, round up. Let's call it 5.2. Give this the benefit of the doubt, okay? But for basically, the total time was 12 seconds compared to 22 seconds, right, before virtual threads. The slowest request took 6 seconds. Here, it took 3 times longer than that, more than 3 times longer than that. The fastest, let's say 5.1, it should be, I mean, if it only takes 5 seconds to get a response, then it's going to be 5 seconds plus network latency, right? Okay, good. And then the average here is 5.5 seconds. Here it's 8.3 seconds. So almost, a lot more, right? 60% extra. And then here, the number of requests is 1.7 per second. Here it's 3.2. So more than double, almost double. An amazing result. And all we did was turn on virtual threads. This is free in Java 21. So I think the answer is yes. Our code is very, very, very scalable. Now, is our code fast? And friends, this is written in Java. How many of you have seen the 1BRC challenge? Who saw the 1BRC challenge? This was put out by our friend Gunnar Morling, my friend Gunnar Morling, fellow Java champion. Earlier this year, he asked people to submit a program to tabulate some statistics for weather station telemetry data. So city, comma, temperature. And there's 1 billion rows in text. So you have to write a program using stock standard Java, load what amounts to be about 13 gigabytes of text, calculate some statistics, and then dump it out, and then exit. How fast do you think if you know the answer, don't answer, but how fast do you think the fastest entry is? 13 gigs of data. You have to load it and then do some statistics and then exit. Well, there we go. 1.5 seconds. Yeah, I heard some swear words. Yeah. That's an amazing result, okay? Now, come on, 1.5. 1.5 seconds. Number 2 is 1.58 seconds. Number 3 is 1.6 seconds. Number 4 is 1.88 seconds. Now, to be fair, the fourth one is using stock standard OpenJDK. The first 3 are all using GraalVM, right? And if you look at the code, this is not like regular code. They're doing some gnarly mad scientist kind of stuff in here. But still, the fact that you can get this with just the regular JDK should tell you all you need to know about Java being fast. It's breathtakingly fast, okay? Now, but that said, these are all using GraalVM, and I quite like GraalVM, so let's also use GraalVM. The problem with GraalVM, if there is any, is that, first of all, it needs to be aware of any dynamic things that you're doing. So I have this dog adoption suggestion. I need to tell GraalVM that I'm going to do reflection as I'm doing there for the response, okay? And then I'm going to need to compile a native image. So I'll do this. Skip tests, p native, native.compile. And this is my least favorite part about this technology is just how long it takes for the native image to compile. It takes a long time, okay? And I do not like waiting for this. And it reminds me of this. This is the XKCD cartoon that posits that the #1 program excuse for legitimately slacking off is my code is compiling. These idiots are swashbuckling on their chairs. The boss says, hey, get back to work. Compiling. Oh, carry on. I get this joke now. I didn't want to get this joke now, but I do. And it reminds me, this long compilation, it just goes on and on and on forever and ever and ever. And it reminds me of elevator music. You know that interminable, endless music that you hear in the lift that goes on forever? It reminds me of that. And I thought, because I already hear this. When I do these long compilations, I thought, wouldn't it be great if everybody else could hear this as well? So I went to Oracle. And I said, please play elevator music during the native image compilation process. I said, I already hear elevator music in my head when I do these sometimes long-running compilations. I'd just like everybody else to hear it too. Thank you in advance, and I appreciate your amazing work. And I do. And I got some great responses, but my favorite was from this one. This is Dr. Fabio Niephaus. He's a researcher on the GraalVM team at Oracle Labs. He'll be here this week. He's a doctor, and he responded. He says, thanks for your feature request, Josh. The problem with playing music during the compilation process is that it only fixes the symptoms, and we're still working on the cause, making GraalVM native images more efficient in terms of time, memory, and CPU consumption. Go on. I have prototyped the -- Josh Long mode. So, what this would do is you'd run the native image compiler. Native image, -- Josh Long mode, hello world. And then you'd hear music. So you'd be like, who did this to me? Where's this music coming from? Then it would say, music brought to you by Josh Long. You're like, oh, okay, I feel better. But still, you're still waiting. You want something nice to look at. So then it would print me out, right? Which I think is going to be a nice addition to the compiler. I don't know when it'll get merged. You can ask Fabio, okay? Anyway, what were we talking about? Oh, right, the compilation. Did that ever finish? Yes. Oh, that's quite embarrassing. That actually finished a little while ago. So let's go here to the target directory. There's our native image binary service. Run the service. Oh, port is blocked. Let me go over here. Stop the process. Okay, there's the application in 0.1 seconds, complete with AI and with everything. And I had to disable the security for our demo, but it would work as well. So, and the best part, of course, is this. You take this process identifier, PS-O RSS, measure the RAM in kilobytes. So this is 121,000 kilobytes. So you divide it by 1,000, it's 121 megabytes. For a modular application with AI, a web server, observability, and security that starts up in 1/10 of a second. Friends, I'm gonna go to my least favorite browser ever. Okay. Oh, don't even. Yeah. Okay, just pick any other page. It's still not loaded. Waiting for a stupid JavaScript app to do its thing. Come on, take your time. Really, we can all wait. 901 megs. 900 megs of RAM to load a stupid JavaScript app that took forever to load. We live in amazing times, my friend. We live in amazing times. I hope I persuaded you of that. I hope you got something out of this. Thank you for coming. Who learned something new? Great. Who had fun? Great, me too, except for that AI business in the middle where we had this weird bug. Otherwise, it was great. Thank you, everybody. Thank you.
All systems are nominal. Initialize Genesis